It's my pleasure to introduce Dr. Robert Zubrin, an American aerospace engineer, a book author, also famous for his Mars Direct proposal, the founder of Mars Society, and a big supporter of Ukraine. Thank you for coming.
Thanks for inviting me. It's my honor.
Yeah, I mean, you've traveled all the way from Denver. It took you, 4 days to come here?
Just about.
Yeah, appreciate that. And as we're filming this is, the 17th of June, 2023. We are in Kiev, Ukraine. And I guess you've experienced a couple of air raid alarms already. What were your impressions of that?
My strongest impression was of the way the Ukrainians took it, which was just shrugging it off. Here in this studio, there's a sign there of the British slogan, "Keep calm and carry on," which was the slogan during the Blitz on London. And they did. And it's why Hitler's attack on London was one of his biggest mistakes. He wasted bombs trying to panic people who wouldn't be panicked instead of using them to destroy the British Air Force. And so Putin right now is wasting missiles on Kiev. He's making no impression at all on the Ukrainians. And he's going to be sorry he wasted missiles on people who couldn't shoot back, that he won't have them to use against people who can.
Right. Yeah. No, I think this is just such an interesting experience for everyone coming here. It just, you can read about it in the newspapers so many times, but once you feel it, it probably feels different, right?
Yeah, no, I mean, actually, the impression of Kiev in the West is of a city under siege that people advised us not to come, too dangerous, etc.
Right.
But look, this is my third visit to Ukraine. I was here in Soviet times. I was here in 2018, and I'm here now. And in 2018, I was surprised by how much Ukraine had changed from what it had been like in Soviet times. It was totally different. It was not an ex-Soviet city. It was a lively European city. Now, this time, I'm surprised by how little it's changed since 2018. It's still a lively European city. It's still cheerful. I do not sense fear in the streets at all. I mean, sure, there's evidence of the war. There are people collecting money for the refugees in Kherson and stuff like this. But, this is this is a city that's filled with life and is not in any way being terrorized by the war.
Totally. I can only double that. Well, Luke, so we plan to cover a lot of ground today and obviously talk about some of your life's work and interests in engineering and space, Mars colonization, nuclear energy, and a number of political topics as well. But actually, as you talk about 2018, I remember how we met for the first time, and it was one thing that was striking for me as I was listening. Maybe it was a YouTube talk with you or something like that. And I remember vividly you arguing on a certain topic and almost like casually remembering Holodomor as one of the humanity's great tragedies. And for me, that was like a friend or foe marker. Like I was, oh my gosh, this man knows what a Holodomor is and speaks about it. And wow, he's so knowledgeable about the history and the history of Ukraine in particular. That was very interesting. How did you first learn about that?
Holodomor, okay, the hunger death. Well, I read history. I can't remember when I first read about it, but it was some time ago. It wasn't right before I came to Ukraine by any stretch. I had known about the Holodomor for some time. I knew about the history of the 20th century.
Yeah. Well, that's just impressive. I never shared this with you, but I just felt like sharing that piece. And there was this guy, actually a New York Times reporter who got Pulitzer, Walter Duranty, who was famously or infamously chief of a New York Times office in Moscow during the Holodomor time, and he was basically covering Stalin's terror.
As were the Webbs.
And he got the Pulitzer, and yeah, there's a nice movie about that, Mr. Jones. Yeah. Anyhow, so back to our topics. I wanted to start just talking a little bit about yourself and sort of how you sort of came into being who you are. And I often am asked if Robert Zubrin is Russian. He has like a Russian last name. So tell me the story of that last name.
Well, my grandfather was from Odessa.
Right.
Okay.
So that makes you Ukrainian or
Yes.
Russian or Jewish or what?
Or all three.
Okay.
Okay.
And you're American.
And I'm American. I'm as American as apple pie. My concern about Ukraine is not ethnic in nature. I mean, to the extent I speak any language of the people around here, it's Russian. Okay, although, as you know, the large majority of Russian speakers in Ukraine support Ukraine against Moscow. This is not an ethnic war. This is a political war. Okay, between a slave plant empire wanting to conquer an additional province and the people there not wanting to be part of it. But to the extent that language plays any role, I speak a little Russian and only a few phrases of Ukrainian. But no, the fact that I have some Eastern European roots perhaps makes me pay more attention to what's going on here. Than would otherwise be the case. I am more aware of the history of the place, as you said, the Holodomor and other things, and I know who various important personalities of the history of this region are and what they did and so forth. But my take on it is really from an American point of view. In 1858, almost exactly 175 years ago today, because it was June 16th, Abraham Lincoln gave a famous speech in which he said, "A house divided against itself cannot stand. I do not believe that this nation can long endure half slave and half free. It must become all one or all the other." Okay? Now, the forces of freedom won that war, but the world today is a house divided. It is half slave and half free, and I do not believe it will endure in perpetuity that way. It will become all one or all the other. And I see this war as the fork in the road that will have a great influence on which way it ends up.
Totally. Let's maybe we'll get to the war as a separate topic, but tell me a little bit about how you became an engineer. How did you were born in Brooklyn, right?
Yes. Okay. Well.
Was it something you felt like from the age of 3, or how did that happen?
More like 5.
Okay.
I was 5 when Sputnik flew.
Okay. That's how it happened.
Yeah.
So give my regards to Serhiy Korolev.
That's right. Give my regard to Korolev. Yeah, the adults were terrified of Sputnik, but I was delighted with it.
It made nice sounds, right?
Beep, beep. No, but the thing, you could see it, And the thing was, I was an early reader, and I was already reading science fiction. And
in the age of 5.
Yes. And what Sputnik said to me was that these stories were going to be true, that this was real, that we were going to be space travelers.
Right.
And so I wanted to be part of it. And my parents encouraged my interest. You know, my father got me a telescope and I did drawings of the moon through the eyepiece and stuff. And we launched rockets and all that kind of thing.
You launched rockets as a kid with your father?
Yes. And you could buy rockets with simple kits. You could put them together and launch them in the park.
Right.
We did. And I read all sorts of science.
Not much of regulations back then, right? You could just go to a park and launch a rocket. Probably you couldn't do that in Central Park these days.
I think you could.
What would be the consequences of that?
You'd probably lose your rocket. You'd lose your rockets. Somebody would steal it when he came down. But okay, so that's changed. But anyway, so I was into it. And, so I'm 9 years old when Kennedy gives his speech committing us to go to the moon.
Right.
We saw that on TV in my fourth grade classroom.
Wow.
And
the famous, we're doing this not because it is easy.
Well, no, not that speech. That was given at Rice University a year later.
Okay.
It was the speech to the Joint House of Congress in '61. So anyway, but that was incredible. And so we were going to the moon by 1970, Mars by 1980, Saturn by 1990, Alpha Centauri by the year 2000. That's the program. Count me in, right? Okay, so I learned all the science I could. We were going out there. And of course, we did get to the moon by 1970. In fact, we made it there by 1969. But then at that time, okay, Nixon had gotten elected, administrations had changed, and this whole Apollo push to the moon and then on to Mars, and NASA had plans to land on Mars by 1981.
The race with the Soviets was sort of won.
We had won the race with the Soviets, but also the whole Apollo thing was a Kennedy-Johnson deal, not invented here. And so Nixon canceled it. Mm-hmm. And this happened while I was in college in the early 70s.
You were in college in the moment.
Yeah. Now, you have to understand, I'm the first generation of my family to go to college. Okay.
Wow.
So the idea of college was, okay, if you go to college and you can get a good job, right? Okay. So it's time to grow up. You're now in the middle of college. This Apollo thing is over, and get real. In the astronauts and space explorers are the people that live on the other side of the television screen, along with the movie stars and other people in that world. The people in our world are policemen and teachers and accountants and so forth. So choose your good job that you can now get once you're getting out of college.
Right.
Okay, I'll be a teacher. I knew a lot of science. I could become a science teacher. And I did. And I did that off and on for 7 years. These were actually pretty tough economic times in the 70s after the oil breakup. And
so you said you were a science teacher.
Yes, I was.
What did it mean to teach science in the U.S. back then? What is that like? Physics, chemistry, engineering? What is the combination of these?
It was biology, chemistry, and physics.
Uh-huh.
Okay, and I knew enough of all of that to teach all of that, and mathematics too.
And that is basically school. Which grade?
It was
is that?
mostly secondary school, junior high and high school. Okay, so I'm doing that first in the Buffalo area, and then later on back in New York, and there I am, and it's like 1983. And I'm living in northern Manhattan and teaching in Brooklyn and taking the A train an hour and 15 minutes each way and reading novels by Herman Melville about sailing the South Seas and saying, what am I doing here? Okay, right. What am I doing here? Now, by this time, I became aware of this thing called graduate school. Okay, graduate school didn't even cross my radar when I was an undergraduate. It just I was aware that there were people called graduate students because they graded papers, but it wasn't that I rejected the idea of graduate school when I was in college. It didn't even occur to me.
It didn't come to your mind, right?
No, it just wasn't even there. It was you went to college, then you got a job.
Yeah.
Okay. But now I had heard about it, and I had realized that this life of, also being a teacher in New York City is the pretty limited life economically and so forth. So I applied to graduate school, and I got into several, including Columbia University, which is right there in Manhattan, not far from where I was living. I wouldn't have had to move if I went there. And the University of Washington, which is in Seattle, on the other side of the country. And so I went there to check it out, and it's beautiful. And I took a day and went up Mount Rainier, the mountain, and you could see all these other peaks around, and it was vast, wide open. I said, this is for me. So I bought a car for $1 from someone who thought that it was doomed, and made it, like to Pennsylvania when it broke down, and got it fixed, made it to South Dakota, broke down, got it fixed, made it to Seattle. And I enrolled in nuclear engineering, controlled fusion, because at that time, I thought that development of fusion power was the main important breakthrough that was going to occur in the remainder of the 20th century.
Soon. Definitely coming soon.
Yeah, coming soon.
That's what it felt then.
Yeah, and it was, the next really big thing. Okay, and of course it is a very big thing. But while I was there, a couple of things happened. One thing is the U.S. fusion program was contracting. There had been a rich array of alternative concepts being researched, and all the alternative concepts were limited to the tokamak, one concept. And in other words, there was decreasing opportunity for creative thought in the program. It was all refining the tokamak. And I was very aware of what was going on because my graduate advisor, my professor, Fred Reby, was the chairman of the Magnetic Fusion Advisory Committee. He had been the head of the fusion program at Los Alamos, and so now he was sort of in semi-retirement and advising the whole program. Anyway, and in the meantime, I hear about these people over in Colorado who were holding these conferences called The Case for Mars. And these were people of my own generation. These were, as it were, also Apollo's children, who objected to the fact that the U.S. space program had been contracted from, storming heaven to running space shuttles. And they were holding conferences called The Case for Mars. And I heard about the first two, and I went to the third. And there were 1,000 people there. Carl Sagan was there. Thomas Paine, who had been administrator of NASA when we landed on the moon, was there. And here was Mars, the Mars mission, which is such a multifaceted problem with propulsion and life support and human factors and scientific investigations and all these different things that had to be optimized against each other. It was such, first of all, it was my first love, space and Mars.
Right.
And second of all, as an engineer, and this was just great stuff. I wanted to be part of this. And I met the guy who was leading the Mars mission studies at Martin Marietta, which is now Lockheed Martin, Ben Clark. And I told him, about what I had studied and what I was interested in. He said, send me your resume. I sent him my resume, and a year later I was working at Martin doing preliminary design of interplanetary missions. And
that's where it basically starts your sort of
yes.
Your long-standing fascination with Mars, colonizing it, terraforming it, and then further exploring the space and so on. And you wrote a book titled The Case for Mars.
Yes.
Which is basically an homage to that conference, I guess.
Yes, it is. And to those people who were at that time known as the Mars Underground.
Yeah. So for our listeners and viewers, why should we go to Mars? why are you and so many bright people around the world excited about this idea and keep being excited about it for decades now?
Well, there's 3 reasons. Mars is where the science is, Mars is where the challenge is, and Mars is where the future is. It's where the science is because it's the Rosetta Stone for letting us know the truth about the prevalence and potential diversity of life in the universe. The early Mars was very much like the early Earth. Okay, we were born twins. We went off in different directions, but for a while, we're pretty similar. We were both warm, wet planets with CO2-dominated atmospheres and rocky surfaces. And now life appeared on Earth. If you say similar conditions should cause similar results, then life should have appeared on Mars. Even if it subsequently went extinct when the conditions on the surface of the planet deteriorated. And if we can go to Mars and even find fossils of past life on Mars, then you will have proven that life is a general phenomenon in the universe. That is, the development of life from chemistry on Earth was not an exceptional event caused by some weird combination of chance.
Right.
If it happens at 2 out of 2, it's causal, okay? But furthermore, I believe that if there was ever life on Mars, when conditions on the surface deteriorated, which they have, that it would retreat into places where it could continue to carry on, which is to say in the groundwater. We're talking about microbial life.
Right. So just sort of to sum that up, are we pretty much sure at this point, and by we, I mean just general science, that there is no life on the surface of Mars, or is there still a chance, you think?
Oh, there's a chance that there could be life on the surface of Mars. Extremophiles.
A small one. A small chance.
Yeah. There's some people argue that it's probably there because there are extremophile organisms that could endure through the Martian conditions for some time. But I think that while you have many life forms that could survive in dormant form on the surface of Mars, they have to come back alive periodically at least. And so maybe, but for sure there could be life in the Martian groundwater.
So a much higher probability that we could find something in the underground water, which we currently know that it exists on Mars in vast quantities.
Yeah, Mars has a liquid water table.
Yeah.
And, the original organisms that lived on the surface of the Earth can no longer survive on the surface of the Earth because to them, oxygen is toxic.
Right.
There was no oxygen in Earth's atmosphere in the period in which they evolved. Then green plants put oxygen in the Earth's atmosphere, poisoning it for them, making it good for us, but poison for them. So they retreated into the groundwater 3 billion years ago. They're still there. Carrying on. Okay, they keep calm and carry on. And they've seen the trilobites come and go, and the dinosaurs come and go, and the Wehrmacht come and go, and they're going to see Putin come and go, and the rest of us. But they're there now. Here's the thing: if we can go to Mars and drill down 0.5 kilometer or so, we could reach the water table, and if there's life in it, we could bring it up, and we could see what it's made of. And this is really important because, you see, all life on Earth uses the same information system. In fact, it uses the same alphabet, DNA and RNA. Now, as an American, of course, we use the Latin alphabet, and so do the French and the Spanish and even the Poles. And if you only knew the West, you would think that the alphabet is the Latin alphabet.
Right.
Okay, but you come over here and you have a different alphabet. You have the Cyrillic alphabet, which you have in common with the Russians and the Greeks and Bulgarians, okay? So there's another one. Now, that's somewhat different from our alphabet, but it uses the same basic principles, okay? And even many of the same letters, though not all. And some of the same letters mean different things. But it's still an alphabet. It works the same way. And even the Hebrew and Arabic alphabets, which look completely different, work largely on the same set of principles.
Right.
But then you go to China,
Yeah.
and they have an alphabet that doesn't just look different, it works differently, completely differently. And it's not even based on the same fundamental concepts of making sounds out of letters. It's assembling pictures into concepts. And yet you can write books in it, and they do. So it's a different information system. Well, similarly, life on Earth all uses the same information system and the very same alphabet. Does Martian life, well, it has to have an information system to be life, but it doesn't have to use the same information system. It could use, instead of the Latin alphabet, it could use the Cyrillic or the Hebrew or the Chinese. Or maybe the analogy is closer to computers, where the first computers worked with gears and levers and stuff like this to do calculations. Then they had ones that used electrical relays, and then vacuum tubes, and then silicon. And now there are people playing around with DNA computers and things.
Right.
Okay, and these different types of computers have different capabilities, and they can do different things. And when you went from vacuum tubes to silicon, you could do all sorts of things you couldn't do before. And maybe there are biological information systems out there that are to be found that offer greater potential than the one we use here in the sense of for biotechnology, which, of course, is going to be one of the main science and technologies, technological fields of the 21st century is going to be biotechnology. Biotechnology is the real nanotech. Okay,
so is that sort of the most exciting question regarding the life out there for you? Which alphabet does it use? What does it look like on the most fundamental level? Or what are the other questions you have for extraterrestrial life?
Oh, I have plenty of questions about extraterrestrial life. But in terms of Mars as being the place where we could actually get our hands on some, we may discover extraterrestrial life with the Webb telescope by detecting oxygen in the atmosphere of exoplanets. To me, that would be a signature for life because oxygen is far outnumbered in the universe by things that want to react with oxygen, like hydrogen, carbon, silicon, iron, aluminum. Okay, they all want to react with oxygen. And so if you have free oxygen, that means something is breaking the compounds apart, like plants turn CO2 and water into oxygen and hydrogen and carbon. Okay, that's a disequilibrium thing. It requires a engine of a kind, a biological engine to make it. And so if we find a planet out there with 20% oxygen,
we know there's life there.
I would. I mean, there'd be scientists that would dispute it here and there in order to be picky, but really that would say to any sensible person there's life there and in quantity. Now, there was not free oxygen in Earth's atmosphere until there was a lot of life here. Now, when it first started out, and for a while, for about a billion or 2 years, there wasn't much oxygen. It took a while to build the oxygen up. So you could have life without oxygen, but you can't have oxygen without life. And so we might detect it that way, but we wouldn't know much else about it. But if we go to Mars, we can get our hands on samples.
It's different, right? Yeah, we can touch it, we can study it, do all this stuff. But let's we'll talk more about Mars. But here we sort of come to this question that bothers so many of us. Like, where are all the aliens, right? The Fermi paradox, right? We have billion stars in our galaxy. We have billions of galaxies. We have almost 14 billion years of universe age. And we have not yet seen any signature of alien life. It couldn't be that Earth is so unique. So, hence the Fermi paradox. What is your answer to Fermi paradox?
Well, once again, we may get the answer from Mars. And I'll tell you why. The question is, where did life on Earth come from? is life on Earth truly native to the Earth, or is it an immigrant phenomenon? Okay. Now, the theory that life could be an immigrant phenomenon, well, first of all, it's possible. But second of all, what would lean one in that direction? It's the fact that we don't find any evidence of free living organisms on Earth simpler than bacteria. Okay. Viruses are simpler, but they're not free living organisms. They are degenerations from bacteria. Okay.
Right. They cannot exist without the other organisms.
Right. Yes.
Yeah.
Okay. But here's the thing: bacteria are really pretty complicated things, and they have this whole information
It's hard
system.
to imagine that was like the first life that ever emerged, right?
Correct. So this is why, well, as far back as like the 1890s, the Swedish scientist Arrhenius speculated that life on Earth could have been planted here by bacterial spores coming from space. Now, origin of life theorists hate this theory called panspermia because it ducks the question. They're interested in how chemicals get to become life, and this.
Right. Well, even if it came from somewhere away from Earth, well, how did it was born here? There, where it came from?
Yeah. So
right?
the questions remain. In fact, I believe it potentially could provide clues. I'll get to that in a minute.
Right.
But here's the thing. Okay. So we find no pre-bacterial organisms on Earth. Now, if we go to Mars, there's basically four possibilities. One is there's no life on Mars. Okay. That would strongly indicate that life on Earth originated on Earth, because if life on Earth came from the outside, it would have gone to Mars too. Okay. Now, there's another possibility. There's life on Mars, which is totally different than Earth life. Well, that would once again indicate that life on Earth came from Earth and life on Mars came from Mars, separate genesis. And that'd be very interesting. Okay.
And that would indicate there is high probability of life having independent genesis on many other planets, right?
Exactly. Okay. Then there's another possibility, which is that you find life on Mars similar to Earth life in the fundamental sense, but including pre-bacterial evolution. That would indicate that life on Earth came from Mars. Okay, now as you find the early history of the Earth life on Mars, just like we can tell that, American civilization came from Western civilization in Europe, you could identify, you can't find any runes in America of Western civilization that predate the Renaissance, whereas you can in Europe. So there's the prehistory. Okay, that's another possibility. But what if we find life on Mars that is identical, fundamentally identical to Earth life, and no pre-bacteria? To me, that would prove that they were both seeded from the outside. Neither have a history before bacteria, and both were seeded from the outside. Now, okay, so that means that life is spreading through the universe through bacterial spores. Okay, now, it's possible that that's a natural phenomenon. Okay, and in fact, that's the more likely hypothesis. But another hypothesis is they're being spread artificially.
Well, artificially would mean but by some other more advanced civilization.
That's right.
Which in its turn had to have some sort of origin.
Well, true. But the idea is you ask, what's the evidence for aliens? My
question is rather, why aren't we seeing any evidence for aliens? I mean,
what I'm saying is maybe you are.
Okay.
Maybe you're seeing them all around you. Okay. In other words, if life on Earth is the result of a program of panspermia launched by aliens, then we are them. That is, if you say, okay.
Well, I mean, let me restate that. So I mean, the Fermi paradox and sort of the Drake equation, they say, well, here's like the Drake equation. Here's the formula that tries to estimate how many other like radio signal emitting civilizations are there in the Milky Way galaxy at this given moment of time, right? And it goes with 7 different coefficients, and it has a range for each of them, and it arrives to a conclusion that even by the most conservative estimates, there are like thousands of radio capable of sending radio signals civilizations that are currently alive somewhere in the Milky Way galaxy. And then you have sort of the empirical evidence, which is we've been listening to them, we've been trying to talk to them, like communicating. We've been looking at the skies, looking for sort of heat signatures for, with more or less good equipment for at least 50 years now, probably arguably more than that. And we have not seen any evidence. And these two things, they're conflicting: our sort of empirical experience and sort of the most conservative estimate for a Drake equation. And then all the different theories for that, which I'm sure you're well familiar with, and sort of like the dark forest or the rare earth, they all sort of break against this wall that either something like rare earth should happen with almost 100% probability, or if it doesn't, we should still see some other civilizations because they would have developed, they would have spread throughout the galaxy. It's almost impossible that like we would see 0 of them. So that's what bothers me in this whole
Okay, well, let me try to answer some of this
thing. Yeah.
Okay. Frank Drake came up with searching for radio signals because he had radio telescopes at his disposal. And in fact, they came up with an argument that it should be at a certain frequency, and there were plausible arguments for this particular frequency, but also it happened to be the frequency that was used for satellite communications circa 1960. Right. It was known as L-band. It's already obsolete. We don't use it anymore. So it's a transitory technology. It's like looking for Martians by looking for the emissions of their gas lights. You're looking for a technology which is of a specific time. Now, furthermore, okay, so you say, well, what if they were using more advanced space stuff, like, for instance, the X-band transmitter, which is on the Mars Reconnaissance Orbiter? Well, that can transmit at 6 megabits a second from Mars to Earth. If you put that at Tau Ceti, it would transmit to Earth at 6 microbits per second, okay, which is, say, completely impractical technology, a couple of bits a year, okay? And that's if you're pointing it at Earth, okay? And maybe somebody even did that, 3 million years ago for 1,000 years and then gave up, okay? How come the Earthlings are not replying? Okay, well, maybe it's because the mastodons didn't listen. But directed radio is not an effective means of interstellar communication unless you yourself have established the receiver at the other end, and you're willing, therefore, to broadcast not with hundreds of watts, but hundreds of gigawatts to get a meaningful transmission rate to someone who you know is there. Now, let me talk about other methods of interstellar communication.
Then there is this also argument that any sufficiently advanced civilization would use more and more energy, which I think you also sort of ascribe to, and you've mentioned that numerous times in your books. So civilization using that energy, the energy use would have been seen from the outside, and even if it's less than something like a Dyson sphere, say. So what you're saying is that we do not yet have an imagination to imagine what these alien civilizations could do?
Maybe. I'm telling you, Frank Drake didn't.
Right.
Okay, now there's other possibilities. Okay, I think we'd be better off, well, first of all, looking for oxygen, okay, to find life. But to find techno-signature, if you're looking for technology signatures, okay, he was looking for radio transmission as a techno-signature. Okay, how about things that are intrinsically high energy, like starship propulsion systems or artificial suns? And now we're getting more speculative. But I have written a couple of papers in this area about what a starship drive might look like as seen from here and what would be required to detect it. I've looked at also a very useful technology would be the creation of artificial suns. And there's certain ways in principle, at least one could do that.
Which is sort of a controlled fusion.
Well, actually, it's creating artificial black holes and feeding matter into it.
That's
if you did it with controlled fusion, it would look very much like a natural star. And it would have to be very big. A much smaller object would be an artificial black hole. Now, that would look different than a star. And in fact, you'd probably have to put a mass around it to take the hard radiation that it would emit and thermalize it down to thermal radiation. And then it would look like a K-star, a red dwarf, except, here's the thing, it would be much smaller than an actual red dwarf. And so, if you look at any astronomical plate, you see the prominent things, and in the background, thousands of undistinguished objects are just littering the plate. Okay, now, and most of them are just normal stars at a great distance, and they just sort of cover the plate. Well, what if one of those little undistinguished objects, if we did a study of them and we took plates on this side of the Earth's orbit and that side of the Earth's orbit, and we saw that this little undistinguished object right over here moved a little bit when we went from one side of the orbit to the other. Then notice that it showed parallax. That would mean that it's not a normal star at a great distance, but a much smaller star closer to us. Okay, a star that's too small to be a natural star, okay, but nevertheless it appears on the plate because it's close enough to show up on the plate.
Right.
In that case, you would have detected an artificial sun. And I believe this is actually a search that could be done if someone wanted to do it, searching astronomical images and trying to, you'd have to have a computer to do it because you'd be looking at millions of undistinguished objects, but to see if any of them show parallax, okay? Because these sorts of things, whether you're showing starship drives or artificial suns, they're very high energy compared to radio transmitters, but they're very low energy compared to a star. So therefore, if you can see them at all, they're going to be a lot closer.
Are you aware of any such program trying to look at this phenomenon?
I'm trying to
currently
encourage people to do it. Okay.
But then you say about trying to detect oxygen, and that, as far as I know, is happening actually. And not only for oxygen, I think people are trying to look for some other gases that could signal life as well. In fact, there was this scientist, I believe like 3 years ago, she claimed that she saw some signatures in the atmosphere of Venus, which could signal life. And the way they do this, they basically analyze the light spectrum coming through the atmospheres of certain planets, and then certain wavelengths of light are being blocked by certain gases, and that's how you can know whether a certain planet has a certain gas in its atmosphere. And then the Webb telescope is now studying exoplanets famously. So do you expect all of those sort of atmospheric studies programs to bring some results in near future?
Yeah,
what are your thoughts?
Yeah, I
do.
I think that, the whole science of exoplanet studies is really broken out, and people are devising techniques, and even Hubble, but also the Webb, and then there's the telescope that was called the W first. I think it's now going to be called the Nancy Roman telescope. To be launched later this decade. But especially Webb, it's up there now. It's doing well, and it's got a lot of capability. I think there's a good chance we're going to see oxygen in an exoplanet atmosphere this decade. And then once we see it once, I think we're going to see it in 1,000 places. And once the technique is demonstrated. And then that's going to let us know that we're living in a universe that's filled with life, but it's not going to tell us much about that life. Now, the techno-signatures are harder. As I said, the radio doesn't really cut it. Once again, you're expecting somebody to be directing a transmitter at you, despite the fact that we have not answered the phone for the past 3 billion years. They're still calling. In other words, the Earth would have shown an oxygen signature for several billion years now. So somebody could look, oh, there's the Earth, or whatever they call us, and they say, it's got oxygen. Let's see if they answer the phone. And no, it gets old after a while calling people who don't answer the phone. And
these thought experiments, they get tricky because, you must think they must be a much more advanced civilization if they've been able to send us signals 3 billion years. And maybe they would have figured out that 3 billion years ago we were like less advanced. And, it's just we get into that speculative territory.
I wrote a paper on this subject. It's a speculative paper. Here's the thing, where I talk about using microbes as interstellar communication. Okay, because they carry information. Now, first of all, the Frank Drake, Carl Sagan vision of interstellar communication is they transmit to you, and they're transmitting the digits of pi, and if you can see that somebody's transmitting pi to you, they're intelligent, and then you transmit to them a similar number. It's like a Freemason handshake that we're both in the club, and then they can send you the dictionary, and then they send you the plans for starships, and so forth. And none of this is actually adaptive in nature. And on the other hand, if you're a certain kind of life, what is the kind of information that people typically send to people they don't know? Propaganda. Okay. And whether you're talking about Radio Moscow, become a communist, okay, join us, okay, or the Gideons putting Bibles in hotel rooms, become a Christian, here's the book. Okay, this is what it is. Propaganda is be like us, okay, and it is an adaptive activity, okay, because it helps a certain type of group of people, in this case, propagate themselves, okay? And those who do not engage in it do not become prevalent, okay? So by definition, political movements, species, cultures, if the ones that become prevalent are the ones that engage in propaganda of one form or another. Okay. So interstellar communication, the most adaptive form of it is a propaganda, be like us. Now, what better way to get other life forms to be like you than to spread your seeds? Okay, so now, people have actually now written books in bacterial DNA, but that doesn't do much good because someone else has to have the whole code and everything. But what if, quite literally, the medium is the message? What if the bacteria are known to have the potential to evolve into certain types of creatures? In other words, that if you have a species that is wise enough to say, if we let these things loose, they're going to evolve into people like us.
That would be how we could colonize other planets. That would be probably one of the wiser ways.
And that's how they could have colonized us. Now, what's the adaptive value of that? Well, first of all, you're spreading yourself, okay? It's reproduction, okay? And reproduction in a sort of a broad context, aside from having spread themselves, and then we are them, so that their survival chances have been enhanced through numbers of places. What if the long-term vision is a populated galaxy in which information is exchanged, so inventions made anywhere ultimately become used everywhere? It is, despite all the conflict between nations, it has advantaged most nations that plenty of other nations exist because we get inventions and literature and so forth from diverse sources, and inventions made anywhere ultimately become used everywhere. So the West has benefited from the existence of China. We got paper and printing from them, and China got electricity and iPhones from us. And that's one vision. So,
you also have spoken and sort of answering to the people who were criticizing the ideas of going to Mars as something that could, contaminate either Mars from Earth or Earth from Mars, which is obviously, at least you and I definitely share that vision, is a crazy idea. Because these systems have evolved on such different time frames that's virtually impossible. But isn't the same rule applied to the sort of contamination by ideas? If you think of two civilizations, what you're talking about, sort of propaganda, it can be also described as contamination by ideas or idea viruses.
Or fertilization by ideas.
Or fertilization, yes. Could be either way, But basically, isn't that as unlikely as biological contamination if two civilizations have evolved in completely different ways, much more different than Chinese and the Western societies here on Earth? How likely it is that we can even understand those messages or make any sense out of them?
When the time comes, when we're capable of understanding it. But for instance, here we are, okay, and while I may be having trouble within the past few years getting people to implement my idea of looking for technosignatures, sooner or later, somebody is going to be convinced to look for technosignatures, either by me or by somebody else, and we will look. And if those technosignatures are out there, at a certain point, our telescopes and the other instrumentation is going to become effective enough to find it. And then one could think of serious methods of communication. If you actually know where to transmit, then you could use much higher data rate methods, like laser communication is better than radio by factors of like 1 million. And the things you could do once you know where the people are that you need to talk to, just listening for people to address us using 1950s communication systems, that doesn't seem to be a good way to look for advanced civilizations.
Yeah, no, agree, makes sense. So to round up the Fermi paradox topic, I got to ask you about one more thing, which is there's this guy, Nick Bostrom, who famously put this simulation argument or trilemma about simulation, which goes something like that either every sufficiently advanced civilization destroys itself. It's like, he says that one of the following three must be true. Either every sufficiently advanced civilization destroys itself, or every such civilization concludes that simulating is deeply unethical and decides not to do this.
Not to do what?
Not to do any kind of simulations of, like, computer simulations of a civilization. Or there is a 99% chance that we are living in a simulation. So this is called sort of a simulation argument. And he says that given, it's sort of more scientific formalization of a thesis that given how fast the technology, the computer technology is progressing in computer games and everything, there is a high chance that, 50 or 100 or 1,000 years from now, we will be able to create virtual worlds that are undistinguishable from the actual world we are living in. If so, how do we know that we are now not living in a simulation? And some people say that such explanation could be an explanation for the Fermi paradox. What do you think of that?
I don't believe it. I don't buy it. I don't think we're living in a simulation. I believe that we are real, that the world is real, and that reality is relevant. That's where I'm coming from, and maybe that's a prejudice, but I think there is such a thing called reality, and therefore there is such a thing as truth. I believe in science. I believe in the search for truth, the search for actual laws of the universe, rather than laws of a game that somebody made up for us to believe in.
Yeah, it's sort of an argument that some people would call ascientific because it cannot be either proven or disproven. It's sort of like arguing about the existence of God. But, however, I think this particular paper by Bostrom is interesting and probably worth your attention.
I'll have a look at it, but I have an intrinsic hostility to it.
That counts for a lot. In fact, intuition, I think, counts for a lot.
Yeah, no, I believe there's such a thing, reality, and we're living in it.
Right. Do you also believe in the free will? By the way, where do you stand
I do.
on that side of the
argument? I do
argument?
believe in free will. Look.
No determinism there. The physics breaks down on that level, or what has happened there?
Okay, look, here's the thing. Okay, I'm not saying there is no God, but people who argue for the existence of God are arguing against the data. Okay, the readily available data. They have to explain a lot of things to justify that. On the other hand, people who argue against the existence of the soul are arguing against the data. That is, because that's something we all experience directly. Okay, they're saying, well, you just think you have a soul.
You just think that you think.
Okay, how can you think you have a whole if there's no soul, if there's no you? Okay, yes, if you want to argue for the existence of immortal souls, well, you've got a difficult position to defend there because you have to explain how all this thinking goes on when the brain that does it isn't there anymore. Okay, but if you argue for the existence of mortal souls, okay, that are capable of thinking, that are capable of free will, okay, you're arguing with the data. You're arguing in accord with direct experience. Okay, and the people who look. Someone says there's no such thing as free will. Your actions are determined. I'm saying, okay, predict what I'm going to have for dinner tonight. Okay, predict which way that bird is going to fly.
Yeah,
they can't do it.
There is sort of this sort of deterministic argument for that, is that if we knew all the trajectories of all the particles in the world, or all the equations for all the particles in the world, we could have perfectly predict anything.
Well, really, can you? Let's do this. Okay, I'm going to give you a computer that knows the trajectories of all the particles in the universe. Okay, and have it tell me what I'm going to have for dinner tonight. And then I will falsify that prediction.
Well, that would be a decent experiment, right?
Yeah, but you see, if it did whatever it said, I could falsify it.
Well, only if you know what it said. Well, yeah. Even if you know what it said, it's sort of it sort of proves that there is free will because it means you cannot predict, right?
Right.
Yeah, that's a good one. That's a good one. Let's leave it there and let's take a step back and talk a little bit about Mars Direct.
Okay.
This can throw 40 metric tons onto a minimum energy trans-Mars injection trajectory, a little more than that actually, and about 50 metric tons onto trans-lunar injection. But what do? At an early launch opportunity, which is really December 96, we call it 97.
Mars Direct is a program that you famously proposed, I believe, in 1990, which was a very ambitious plan to put the first human on Mars. So tell us a little bit about how it went, what was the key plan, and what are the pieces of that plan that are being reused with the current plans of the humanity has to go to Mars?
Okay. Interesting. Okay. So, as said earlier, I got to work at Martin Marietta in 1988 within the group doing preliminary design for interplanetary missions. And so I learned about all the current planning being done by Martin and by our competitors and by NASA. And I was familiar with this whole thing, all this range of studies that were underway. And then in 1989, the elder President Bush got up on the steps of the National Air and Space Museum with Armstrong and Aldrin and Collins, the Apollo 11 crew. And he said, look, this is the 20th anniversary of the moon landing. That was great. That's what America's all about. And therefore, I, as president, am committing us to go back to the moon and on to Mars, and this time to stay. It's great stuff. So, NASA...
The year was...
89.
Right.
Okay. So,
I was born.
Okay. There you go. You were there. Okay. So, NASA then went off and did a study on how this might be accomplished with significant support for parts of it from us at Martin and other major contractors. So we were participating in this, but they were running the show. And they came up with a plan that 90 days later, which therefore became known as the 90-day report, for how this Bush vision might be accomplished. And what they did was they designed the most complex mission plan or program plan you could possibly design in order to make everyone's favorite technology mission critical. And this is the exact opposite of the correct way to do engineering. Okay, the correct way to do engineering is to have the minimum number of mission critical elements. Okay, this is like running a company in order to give out the most money to all of your vendors because you want to make all your vendors happy. Well, if you're running a company, you're not in business to give money to your vendors. You use the minimum number of vendors you can in order to get the job done. So you don't do things to spend money. You spend money to do things. So, but they were doing things to spend money and on a grand scale. And so the plan involved a 30-year program to get to Mars, and it involved building not only a space station, but a giant space station with orbital hangars and cryogenic fuel depots and checkout points and a whole Philadelphia Navy Yard on orbit, and then build a lunar base and lunar stations, and then do orbital construction of, well, actually had to do orbital construction of the moon ships, and then much bigger orbital construction of Mars ships.
Sounds like a super complex
undertaking. It was super complex. It was so complex that, okay, you have to realize we're now talking 1990 or 1989-90. This is only 20 years after Apollo. There were still plenty of people in the business who had been in Apollo.
Yeah.
Okay, and they're asking the question. Here's the question. If we could put a man on the moon, why can't we put a man on the moon? And the answer is that they're being told to do it in the most complicated possible way, for example, in order to make the space station mission critical. Okay, people had tried to interpose a space station on Apollo, and they'd been brushed off. No, we're going to the moon. Okay, you want to tell me I can't do my program until I do your program. No, go away. Okay, but here, everybody who wanted to say you can't do your program until you do my program was said, yes, that's right. We'll do your program before we do our program.
Right. So engineer and Mars enthusiast in you got really frustrated about that.
Right. And it wasn't just me. So a number of us went to management at the Martin Marietta company, and we said, look, this thing is just nuts. Okay, and they had come up with a price tag of $400 billion, which was big money in those days.
Just unimaginable big money.
Nowadays, it's just, okay, but...
pocket change.
Okay, right. Yeah. But then $400 billion really mattered. And and 30 years, and you said, look, if this is where the plan is left, there's going to be no program. And the management, uncharacteristically, said, you're right. We have to contradict the customer, which is heresy in the major aerospace companies.
Right. With national contracts. And
you
it's
don't
not how you talk to the Congress, right?
Or, well, not so much the Congress, but NASA.
Right.
Okay, they're the customer. They want you to say, this is right, everything is right. Mm-hmm. Count us in. And but they said, there'll be no program if this is where it's left. So we prevailed upon them to put together a group, which was called the Scenario Development Group, which consisted of just 12 people in the whole large Martin company, which was over 100,000 people. And I was one of them. And commissioned to come up with an alternative plan that would make more sense. And there were a lot of creative people in this group, and so we couldn't agree with each other. So we actually came up with 3 different plans. And once again, management rose to the occasion. I have to hand it to them. They did not try to reconcile the plans and come up with a company party line. Instead, they said, because you couldn't, the plans were based on totally different concepts of optimization. So they said, we'll just float all 3 plans and see which one catches fire. And the Mars Direct plan, which was the one developed by myself and another engineer named David Baker, was the one that lit the house on fire. It was, in certain ways, the most radical break with all the other plans. In certain ways, it was the most radically conservative of all plans because it went to Mars without any on-orbit assembly or even any orbital rendezvous of any kind, without any advanced propulsion. It was just 2 direct launches to Mars of a vehicle in the Saturn V class. And you must realize, at that time, there were people in the business who had built and flown the Saturn Vs.
Right.
Okay, so...
Totally possible. It's
not totally possible.
Not like SLS of today.
Right. Yeah. We know how to do this, okay?
Right.
And... by the way, we weren't the only ones who were going to NASA at this time saying, look, here's a better plan. Okay, the competition were all going, but they were all going proposing different visions of here's the giant spacecraft you need to build on your giant space station.
And you proposed a way to do it with existing spacecraft.
Well, not exactly existing spacecraft, but with spacecraft in the class of existing things.
Okay, yeah.
Okay. And things that, you could say, oh, we could put out an RFP for that and we'd have that in 5 years. Okay. So it was direct launch to Mars, no on-orbit assembly or orbital rendezvous. And then here was the one thing we added in. Use of Martian resources starting on the very first mission.
You were the first to propose that.
Yes. Now, we're not the first to propose the use of Martian resources. Okay. But the point was the other people had said developing Martian resources is something you do later and it will allow you to cut costs later. Okay, but in the meantime, you had already developed the mega spacecraft.
Right.
Okay, here the idea was not to develop the mega spacecraft, to use the Martian resources right on the start. And then long duration stays on Mars starting on the very first mission. With a very effective field exploration plan enabled by the long stay and the Martian resources. So the one magic trick that we introduced into the plan was the Martian resources. But we're talking here about 19th century industrial chemistry. As we pointed out at the time, the concepts for making methane oxygen bipropellant on Mars was practically the only part of the plan that could have been done in Jules Verne's time. That while it was strange to NASA, it wasn't strange to engineering, far from it. It was something that people knew how to do way before people knew how to get to orbit or even fly airplanes. And if you could do that and knock out all the rest of this complexity by doing this, you'd have a much simpler plan.
And now, obviously driven by that, what is called in situ resource utilization, the methane oxygen was a choice for fuel, which is now being used by SpaceX and
that's
many
why
others.
It's being used by SpaceX.
Exactly.
Okay, now here's the thing. There also was a ruthlessness in our plan that was not in any of the competing plans, because all the rest of the people, including the NASA and the competitors, basically went along with the party line of we must justify the space station, so the plan must include on-orbit assembly or it will make NASA unhappy.
Right, and it was political, right? All the Congress wanted their states and factories in their states to have business from this huge governmental order, and that's why...
And all the different parts of
the
NASA.
whole logics, yeah.
And frankly, the space station itself was being driven by that logic. You know, the Skylab program was started in 1968. It was launched in 73, 5 years from program start to flight. Because they just wanted to get it done, and they launched it in an afternoon. The space station, driven by this other logic, you might say its requirements were must require at least 30 launches, must take at least 30 years to build, must cost at least $30 billion, and should not look like Skylab. And in other words, that was the thing. So they were doing something to spend money. And these other people with these programs based off of that were expanding that thinking. And they were all seeking to make various technology groups and various NASA centers happy. Whereas we were saying, look, you want to get to Mars, we want to get there with the least expensive, with the least fuss and bother. We will use the minimum set of required technologies, not the maximum set. So there was... that was the internal logic that led to the specific solution.
Right. So if we summarize Mars Direct, just like 1, 2, 3. So you had this vision for multiple launches and then sort of...
But direct launches.
No
on-orbit assembly.
Right.
Therefore, no on-orbit infrastructure.
Like first launch brings the infrastructure and sort of the fuel...
Well, first launch... Okay, if you want me to explain the plan itself?
Yeah, just like in a couple. And there was, by the way, a very interesting video of you presenting that plan in 1990. It's on YouTube, and we will link to it.
Oh, yeah.
And I watched it. I think it's like hour and a half long video. It's fascinating.
Okay.
Yeah.
So, direct launch to Mars, which means no on-orbit assembly, which means no on-orbit infrastructure. Mm-hmm. Okay, so you get out of the parallel universe where there are orbital construction yards and fueling depots on orbit, because there aren't.
Right.
Okay. And then long duration stays on Mars starting at the first mission. This is important because the short duration stay has 3 defects. First of all, it's short duration, which means limited exploration is done. Second of all, it actually involves higher propulsion requirements than the long duration stay. The delta Vs, as we call them, are bigger.
Because of the launch window between Earth and Mars, which sort of have ideal launch period every 26 months or what.
Yes.
And basically, if you go and want to return immediately, you will have an unoptimal trajectory, so to say.
And you got to pour on the gas.
Yeah.
So therefore, the short stay costs you more. Mm-hmm. You would think, if you say I'm going to go to Hawaii and I'm only staying for a day, well, you'll save on the hotel bill, and the airfare is always just the same. Okay, but imagine that you want to go to Hawaii for a day, but the airfare costs you triple. So that would be even stupider.
A different consideration, right?
Okay, yeah. So now you're paying more to get less time on the beach. And that's what the short duration stay mission was.
And the time it would take to go from Earth to Mars was, what, about 6 months?
Yes, you could get to
plan?
Mars in 6 months. Then you're a year and a half on the surface, and then 6 months coming back.
And so the plan, as far as I remember, you correct me, the plan was to launch the first rocket, bring the habitat facility, and then the sort of the fuel production plant. And then the second rocket bring actual astronauts who could
You're
could
close.
live there.
The first launch brings the Earth return vehicle and the fuel production launch.
Yeah.
The second launch brings the astronauts in the habitation craft.
Right.
So the first launch lands the return vehicle and fills it with propellant made locally. Then the second launch brings the astronauts to it. And now they fly in convoy with another return vehicle, which is their backup, but which otherwise opens up site number 2. And then every 2 years, you launch 2 more, one to go to the previously open site, one to open up the new site.
Was the plan to launch these both vehicles in a single sort of launch window, or was the plan to launch one first and then another in 2 years?
No. Every 2 years, we do 2 launches.
Yeah.
So within the given launch window, you do launch 2 things. And that launch window lasts about 3 months. So you've got 3 months to get 2 rockets off, okay, which is a doable thing.
Yeah.
Now, but in launch window number, in launch window number 1, we just launched the return vehicle. You could launch a HAB with it, but there would be no astronauts in it. That would just be a backup HAB. Okay. But in launch window number 2, we launch another HAB and another return vehicle. The HAB goes to the landing site of launch number 1, where there's a return vehicle for it. And it goes on a 6-month trajectory. The return vehicle's on an 8-month trajectory. So it's lagging behind. If everything's fine with the first return vehicle, we could either still land that at the same place or we could land it somewhere else. On the other hand, if there's something wrong with the first return vehicle, we could send it to them. Okay.
And the plan was to send 4 astronauts.
Yes.
Or how would you call them? Martian?
I'd call them astronauts.
Colonizers? Astronauts. Okay.
Well, they are explorers.
Explorers.
Okay. Astronaut explorers. I believe that, while one could discuss having the very first people go to Mars go to stay, and there's some advantages to that. That means you never have to build a return vehicle.
There are some disadvantages as well, though.
Yeah, I think that we want to do a certain period of field exploration to find the best place to put a permanent base. So we explore a number of sites, and then we choose the best to build it up as a permanent base. And then ultimately, the job of the base then is to start developing a range of technologies to turn Martian materials into resources, not just fuel and oxygen, but growing food. In other words, we want to have our farms growing before we start sending substantial numbers of people, and also making steel and aluminum and glass and all sorts of other useful stuff. So you basically have some the Martian industry and agriculture going on before you start sending larger numbers of people. And so as these technologies come online, it becomes logistically possible to support not just 4 people on Mars, but 10, and then 20, and then 50, and then 100. Okay, and as these numbers grow, then you have a base with greater and greater research capabilities to develop still more technologies. And then
so that was the Mars Direct plan, right? And you proposed it in 1990. You said it would take maybe 5 years to develop the technology. Well, I can multiply that by 2. I know what engineering takes, but even 10 years would have been so little, right? By the year 2000, we could have been launching the first missions on Mars. And most importantly, the cost of that was probably much lower than $400 billion. What was the cost of the mission you were proposing?
It was 20 to 30 billion.
So ridiculous, right? 20 times or 15 times less than the other.
Right. Now, what happened was, the plan actually caused a lot of excitement immediately, including within NASA, including within some of our competitors, it must be said. Because a lot of people looked at this and they said, wow, this is something we could do. This is humans to Mars by 1999. And once again, this is 1990, Apollo veterans. We started Apollo in 61. We landed in 69. There were people around who had direct personal memories of a time when you could do things in that kind of time frame, okay, that they had experienced it. They had done it. And they also knew, by the way, that Apollo never would have worked if we had tried to do it as a 30-year program, that it would have been canceled somewhere in the middle because the political situation changes.
Yeah.
Right, everything changes. This is, you can't just, stop your tanks in the middle of the battlefield and park them there for a few years, then hope you can just keep going. No, you got to cross. So yes, humans to Mars by 1999. In fact, that was the title of the first public article about Mars Direct. And it was a very doable thing. But then there was the counterattack from the space station people in particular, and other people defending the status quo, said, this is de-justifying our program. We can't have it. If you want us to like you, you better not support this. The advanced propulsion people were against it for the same reason. It didn't use them. And so on. And there was pushback. And so we got into kind of trench warfare. So much so that Baker just left Martin and went off and did something else. But I stuck around. And then there was a change. Mike Griffin, who's a real engineer, got appointed associate administrator for exploration of NASA. And he heard about Mars Direct, and he invited me to come in and present it to him, and I did, and he liked it. So he told me to go back to Johnson Space Center, and he told them that they had to listen to me. So they did, and he listened, pretty much. And they developed their own version of Mars Direct. Now, it was enlarged. They had a crew of 6 instead of a crew of 4. They had bigger ships, and they had more of everything. But it nevertheless, and they had 3 launches instead of 2 per mission. But still, it stuck with the basic principles: direct launch, long duration stay starting on the first mission, use of Martian resources starting on the first mission, no on-orbit assembly, no on-orbit infrastructure, no advanced propulsion. And lo and behold, they costed that out, okay? And they came out with a cost estimate for the program of $55 billion. And these were the same people using the same costing models that had costed the 90-day report at $400. Now, I argued with them. I said, look, you don't need this, you don't need that. You're bigger than you need to be. You don't need this other thing over here. You got too many things of this kind and this and that. And then Carl Sagan said, look, Bob, just calm down. It doesn't matter whether it's 30 billion or 50 billion. It matters whether it's tens of billions and not hundreds of billions.
Right.
Okay, and he was right, of course. And so there we had it. We had the design reference mission incorporating the basic principles of Mars Direct. And then Newsweek heard about it. And this is 1994 now. And it's the 25th anniversary of the moon landing. And Newsweek heard about it. They looked into it, and they said, it's the 25th anniversary of Apollo. Where can we go next? It's Mars. There's now a plan to do it, and it's not going to cost hundreds of billions of dollars. It's going to cost $50 billion. And they significantly featured me as the author of the plan. And so they really got out of the bag that way. And I'm sitting at my desk at Martin Marietta, and the phone rings. Hello? I say, hi, is this Robert Zubrin? Yeah. Hi, I'm Lori Fox. I'm a literary agent. Do you realize you have a book here? I said, maybe. He said, have you ever thought about writing a book? I said, yeah, I once wrote a spy novel. I couldn't get it published. And she said, were you ever a spy? I said, no. Did you have a literary agent? No. She says, well, you are an astronautical engineer, and I am a literary agent, and if you write this book, I will get it published.
Nice.
Okay, and from that came the book, The Case for Mars.
Which was published in 1996, right?
Yes. So The Case for Mars was published in 96.
And it became a sensation.
It was, yes. It was the first run printing, 18,000 hard copies, sold out in 2 weeks. And then they printed it again. They sold out again and again and again, ultimately 150,000 copies. And I got 4,000 letters. 4,000 letters.
Like the paper ones.
Pretty much. There were a few emails, but mostly it was real letters. And they were from all over the world. Okay? And they were from all kinds of people. Yes, I had engineers.
And it's like, I guess the listeners must appreciate that, first, it takes a little bit more effort to write an actual paper letter than an electronic one. And then it's space, and then it's Mars exploration, which is somewhat of a narrow topic to be said. Right. And 4,000 letters for this topic is an insane number, right?
Yeah, but just the diversity of who they were coming from. Engineers from JPL and astronauts, yes. 12-year-old kids in Poland, firemen from Saskatoon, the widow of some guy who won the Congressional Medal of Honor in World War II for sinking a Japanese aircraft carrier, the director of the Metropolitan Opera, a banker in Paris, and another one in Singapore, and the folk singers from Greenwich Village and bomb makers from Livermore, and you just looked at this array of humanity. And I got together with the other people in the Mars Underground, and I said, look at this, look at these people here. And they asked all kinds of questions, but beneath whatever they were asking, there was basically one question, which is, how do we make this happen? Okay? And I said, if we could pull these people together, we could have a movement. We'd have the ability to make something happen. So we used the return addresses of all these letters as our mailing list. And we invited them all to come to Boulder for the founding convention of the Mars Society in August 1998. And 700 people showed up.
Wow.
And it was an amazing thing. And we also had press. We had the New York Times, we had the Washington Post, we had the BBC, and some others. And the was just all over the place. And we came out of that meeting with a society.
And that organization still exists.
It still very much exists.
Yeah. So if I may fast forward to today, back to my original question on this, which elements of the Mars Direct ideas are now being used by existing programs to get to Mars, which are, as far as I know, I'm aware of two, of the one by SpaceX and of another one by the Chinese government. I guess they put some kind of a formal program to put their cosmonauts or astronauts to Mars. Are there any other programs?
Well, there's NASA.
Is NASA, are they currently, they have the Artemis program. Do they currently have the Mars exploration program, like human Mars?
Not really.
Yeah.
Okay. But they have a variety of technology development programs to support the day someday when people will go to Mars.
Maybe.
Okay. And the NASA people have become supportive of development of in situ propellant technology. So, and, I had for a little more than a quarter century a R&D company of my own. I recently sold it, Pioneer Astronautics.
Right.
But we did a lot of work for NASA in the area of in situ propellant production and demonstrated test units that could do it. And some other companies did too. But then Musk comes along. Okay. Now, I have some disagreements with Musk on a number of subjects.
We'll talk on that separately, yeah.
Okay, both political but also technical. But he definitely has the right approach in a number of respects. Okay, when Musk comes up with a Mars plan, he's not looking to spend as much money as he can. Okay, he's not looking to do things to spend money. He's looking to spend money to do things. If you tell him he needs to do something, he says, prove to me I need it. Okay. Now, he developed this plan, which is a derivative of Mars Direct. It is direct launch to Mars, long duration stay on Mars starting from the first mission, and use of Martian propellant from the first mission. His vehicle designs look very different from the particular designs that Baker and I had developed. So those are quite original with him.
Well, you were using just what the legacy you had from the Saturn
Sure.
V missions, right?
Sure.
Apollo missions.
But there was one version of our plan in which we were going to go to Mars and back in the Earth return vehicle, which would look a bit like Musk's plan, except the vehicle was a lot smaller. Because we were thinking going to Mars with 4 people, not with 100. Now, and also we were looking at, look, if this program is going to happen at all, the cost has got to be kept reasonable. And therefore, bigness is the enemy of having it actually happen. Right? If you just get too grandiose, no program at all. Okay, so we pushed for the minimum possible crew, which is 4. That way you can divide the crew up into 2 groups and have no one be alone. But the Starship is an original design with Musk. And it's based on the heritage that he developed with reusable launch vehicles, or mostly reusable launch vehicles, the Falcons. So now he gets the Starship into orbit. He refuels it on orbit with a number of additional Starship launches, and then it flies off to Mars, and then it is refueled on Mars with methane oxygen made on Mars to fly back. Now, the advantage of this plan is, well, first of all, very large payload capability, but also only one flight system for everything. The disadvantage of the plan is, okay, it requires on-orbit refueling, but also the very large Starship, it would take a great deal of fuel, has to be made to send it home. And therefore, large power systems, at least a factor of 5 bigger than those needed for Mars Direct. And
But the goal, I guess their goal is slightly different, because your goal was to, put humans on Mars, do exploration, get back. Musk's stated goal is to actually build a city on Mars that can host 1 million people. So that also is a driver behind some of his designs.
He is focused on settlement. Okay, now, my argument with him, and I have discussed this with him, is A, you want to do exploration before you do settlement, and B, if you want to do that, you want to create a mini Starship that can be lifted to orbit fully fueled by the big Starship, and then that could shoot itself off to Mars without any on-orbit refueling, and refueling it on Mars would be at least a factor of 5 easier than refueling the big Starship.
Right.
And
less fuel.
Okay. And the mini Starship could work in conjunction with the Falcons as a fully reusable upper stage for the Falcon 9, giving you a fully reusable medium lift launch vehicle alongside this. Now, his answer was, I only want to make one flight system. Okay. So if you take his position, the advantage of his position is he only has to make one flight system. The disadvantage is that the ISRU requirements on Mars are a factor of 5 or perhaps even 10 bigger. And a lot of it is waste.
ISRU means in situ
local propellant production. In situ propellant production. Is a factor of at least 5, perhaps 10 bigger. It means the power requirement is bigger. It means instead of 100 kilowatt reactors, you need megawatt reactors. And you might say that to me, as someone who's worked in Mars propellant production, the importance of not having to do it on that big a scale looms large. In other words, you might say, I'm in the trenches on that battle. Okay, whereas he's not in the trenches on that. He's in the trenches on spacecraft development. And so he sees the advantage in not developing 2 systems. Okay, now, But that said, despite the fact that we come to two different conclusions, I do respect the basis of his logic there, which is I want to develop the minimum number of systems. Okay. My minimum is a much smaller nuclear reactor. His minimum is one flight system instead of two. Okay. So those are two different ways to optimize, but we're both looking at the problem in the larger sense in the same way.
Makes sense. And do we know anything about how Chinese plan to do that, or do they keep that under the hood?
I've seen some Chinese stuff where they're pushing giant spacecraft kinds of things. But I'm going to tell you what's really going to happen there. There's at least 5 companies in China right now that are working on duplicating the Falcon 9. Okay. And one or more of them will succeed because laws of physics are the same for everybody, and they are very good at reverse engineering what other people have done. And they will do it. So they will have Falcons or the equivalent, which means they will have reusable launch vehicles. And the idea then, if Musk is successful with Starship, they will copy that. At which point, they may opt for my idea, the mini Starship launched by the big Starship, or they may, in other words, they may stick with what Musk has done, or they may go with the kind of ideas that I like because they're a logical alternative. But that's where they're going to go.
Any other viable ideas you've heard about sort of Earth to Mars missions?
Well, once again, I believe that the humans to Mars missions that will really occur will be using chemical propulsion that, you could have a limited amount of on-orbit assembly, but you don't want to make a Mars mission into a project like building the space station.
Right. Well, one can argue that the SpaceX mission has on-orbit refueling, which sort of an assembly, but in a very small way, right?
Well, yeah, but it's a succession of orbital rendezvous. It's not creating this permanent structure that is to live for a generation or two. And myself, of course, my version avoids the need for orbital refueling. I just think that, you see, using starships to go one way to Mars and keeping them on Mars is interesting for colonization, certainly, or even for exploration, provided it's supplemented by a small Earth return vehicle. But the Starship is extremely suboptimal as a return vehicle because it's so big. And this is true even more for the Starship lunar plan.
So one of your proposals was to actually leave Starship on the Mars orbit and then have, if I'm not mistaken, have a smaller landing vehicle. Am I confusing something?
Actually, I proposed that for the moon.
Okay.
That is, if you were to park a Starship in lunar orbit, and then you have a small landing and ascent vehicle that uses methane oxygen, the Starship could act as a tanker for the little vehicle that goes up and down and up and down and up and down. And to give you an idea of how potent this is, if you want to use starships to support lunar missions with refueling the Starship to go to lunar orbit, then refuel it there to go to the lunar surface and back up to lunar orbit and back home. Depending upon how you do it, it takes between 10 and 14 Starship launches to do a single mission to the moon.
Wow.
Okay. If you did the Starship goes to lunar orbit and parks there, and then you have a small ascent-descent vehicle, it would take 5 starships to get that Starship into lunar orbit, but then that could then support at least 10 sorties to the surface of the moon by a smaller vehicle. So instead of 10 starships supporting one mission, you got 5 starships supporting 10 missions.
Right, but then you would have to develop a separate
vehicle. But you see, but that's the thing. There is a need in real life for some specialization of vehicles. Okay. We don't take ocean liners and use them as cars.
Exactly.
We have certain things we use for traveling across the ocean and certain things we use for traveling on the city streets.
Yeah. Well, no, definitely. I think it's a difficult sort of engineering trade-off always with these systems. But I think both ways should be considered. All right. So we talked when I asked you about the reasons to go to Mars. You named 3 reasons, and we talked about the science. Let's talk about the challenge and the future.
Okay. We'll talk briefly about the challenge, but then I do want to talk some length about the question of the future. Challenge is good. I believe that societies are like individuals. We grow when we challenge ourselves. We stagnate when we do not. And a society that is aggressively taking on the challenge of the exploration and settlement of Mars is going to have a very healthy challenge, particularly to the youth, because the spirit of youth is adventure. And for instance, when we had Apollo going on, it made science the great adventure. The number of science graduates in the United States in the 1960s doubled because of Apollo, and in some fields tripled. And this was at every level: high school, college, PhD.
Are there any estimates of GDP growth that can be directly attributed to Apollo program?
There are, but I think they underestimate it.
Right.
But they're still quite large, because what those are estimates that were done, I think, by Chase Econometrics, which looked at the actual technology spun off by Apollo and how they contributed to economic growth. And there are many, including in computers, solar energy, all sorts of things.
But just in terms of inspiration, just mere entrepreneurship and can-do attitude, all of that.
Well, it's not just attitude. The thing is, if you look at the number of science graduates doubling, and it did, and then the increase stopped virtually immediately after Apollo ended, although it stayed at the new higher level. We've benefited from that intellectual capital, and ever since. I mean, I happen to be unusual in that cohort, and they actually ended up working in the space area. The rest of them went off and built Silicon Valley, and created the whole internet revolution. And then more recently, we found vaccines for COVID literally within weeks of the outbreak of the epidemic. The vaccines had become available for a year because of regulatories delaying approval, but the actual vaccines were discovered within weeks. Tremendous scientific virtuosity. And I'll bet you any amount of money that those teams included biologists that had become biologists because they were excited about science by the space program. So that's really where the true economic payoff was, even more so than the specific technological innovations identified by Chase Econometrics as contributing to economic growth.
That's the challenge, and the challenge is healthy for humanity.
Right. So, but now let's talk about the future. First of all, there's the challenge that people will encounter on Mars. And what is likely to be created on Mars as a result of that challenge. I'm actually working on a new book right now. It's called New World: What Can We Create on the Red Planet? And it looks at...
Just a note from me, your most recent book was just published a couple of months ago, called The Case for Nukes.
Right.
You're already working on a new one. That's, you're my role model for that.
Well... Okay. In any case, so this new book will be published next year. So it looks at what types of societies are likely to emerge on Mars. And in this case, I am not trying to design a utopia. I'm rather looking at this from the point of view of natural selection. Okay. That is, I believe that there will be a considerable variety of Martian settlements initiated. And the question is, which of them will actually grow into city-states and into the prevailing city-states, and therefore the prevailing culture of humanity on Mars. And there's a number of aspects to this. So I look at the technology, yes. I look at what is the potential basis for the economy. I look at the most likely social and political forms. I look at the aesthetics, okay, of all these things. And a lot of things are things that, are right up my alley. And there are things in there that I think will emerge as important that are not my thing at all. But I'm just trying to deal with it straight. But to get to fundamentals, first of all, by definition, the prevailing Martian cities will be the ones that outgrow the rest, which means have the highest rate of immigration and reproduction. Okay, that's tautological. Okay, now, and this is one reason why, for instance, I do not believe that the prevailing Martian city-states will be tyrannies, because no one would want to emigrate there.
So you have to create a really nice place there for people to have kids and go there and so on.
Right, exactly. Okay, and one of the main features of that would be liberty. And so that's a good thing. I'm a very strong advocate of liberty. Liberty is also necessary for the economic prosperity of the colony because, first of all, or even the survival of it, there will be numerous technological challenges, and they will have to be addressed through invention, and liberty is the parent of invention. So it'll have to be a very highly inventive culture, both to meet its own needs, but also these inventions to meet these needs, and I'm going to identify a few of them in a minute, will be licensable on Earth. And therefore be one of the principal exports of a Mars colony will be its IP. And so, once again...
That actually makes sense, right? Not minerals, not some resources, IP, intellectual property, and ideas, and inventions.
Inventions. They are the easiest thing to export across interplanetary space.
Right.
Okay. So, now what are some of the important areas here? First of all, the Mars colony is going to be confronted with a severe labor shortage, both in quantity and diversity of skills. So therefore, as, by the way, the American frontier was, and colonial and 19th century America had a severe labor shortage. And it was addressed primarily, in the North anyway, through gadgeteering. We created labor-saving machinery of all kind to multiply the productivity of labor, which also therefore allowed us to pay people more, which also then encouraged immigration.
Attracted more people there,
yes,
right?
et cetera. The South had an alternative solution to their labor shortage, which was slavery. And ultimately, these two were put into contest, and the free way won because it had the technology, it had the industry, it had the population. And the reason why it had the population is because it had attracted all those immigrants. Do you know 40% of the Union Army were immigrants or first-generation America. Only 3% of the Confederates, the slaveholders' army, was. And, of course, they also created the industry in the North. But anyway, that's I could go on that. But
so
once again, but Mars is going to have to create labor-saving machinery, robotics, artificial intelligence. These are all going to be things that the Martian city-state is heavily driven in. That's the one area.
So would you expect a robotic population on Mars to be actually larger in numbers than the human population? How do you think about that? Do you think about sort of humanoid robots, or do you think about more like specialized robots?
I think they'll be both. There's a need for an advantage to specialized robots for certain kinds of things that are extremely repetitive. On the other hand, humanoid robots are far more adaptable, and I think we're going to see humanoid robots, and I think there's going to be a lot more enthusiasm for them on Mars than on Earth, where they're going to be seen as threats to jobs and so forth.
If we sort of go on a sci-fi tangent here and actually imagine maybe not an AGI, but some form of artificial intelligence that has the roots of consciousness, isn't that sort of, couldn't that turn into the same sort of slavery situation where you have robots that at some point feel like they're not treated in the right way?
Well, then they'll free themselves. But no, that's an interesting situation, and I don't know the answer, except that what I will tell you is the most successful answer is the one that will prevail. This is basic natural selection.
Basic biology. Yeah.
Yes, and the one thing that humanoid robots can't do is reproduce. They can be produced and they will be mature on the day they are made, but they can't reproduce. So there cannot be a society of only robots.
They can make other robots, right? In theory, if they have, but
manufacturing facilities.
It will take a long time until we have manufacturing on Mars.
Right.
But anyhow, you're making the case for future, right?
All right. Yes, but let me continue. So I do believe in this field of automation, robotics, and artificial intelligence, the Martians will be virtuosos. Another field in which I think they're going to be virtuosos is biotech. They are going to have a very severe land shortage. That is, the agricultural land on Mars, they will not have vast open fields. They will be limited to using greenhouses or tunnels, and they are going to want to have ultra-productive crops.
Right, and the amount of nitrogen and other elements that will be, some of them will be brought from Earth, is also a limiting factor. Right?
That's a limiting factor, but the most obvious limiting factor is land and the need to make their small greenhouse acreage ultra-productive, and also do that in the context of a labor shortage as well. Okay. And then finally, and once again, biotech is, I think, going to be one of the driving revolutionary fields of the 21st century. We're already seeing some countries trying to prevent progress in biotech because of the fear of competition with conventional agriculture. This is especially true in the European Union, for example. I think the Martians are going to rip those barriers apart. Then energy. If you want to use fossil fuels on Mars, you're going to make them using some other source of energy. Their solar power is weak. Wind power is weak. We won't have hydro until the planet's terraformed. So that means nuclear power sources, both fission and fusion. With respect to fission, I think the Martians are going to want to have simplified reactors. For instance, for example, homogeneous reactors instead of those with a complex internal structure. That also, I believe the Martians are going to want to have technologies to extract uranium ore from much poorer. Extract uranium from much poorer quality ore.
Are you thinking like Mars regolith or certain sort of mines on Mars that would have
some mines,
but ores which are more uranium rich than an average piece of Mars soil?
Well, they'll go for the most rich thing they can find within a certain distance of the city. But you see, the one thing on Earth, you see, we have global transport. If you want to get uranium from the Congo, you can get uranium from the Congo. Okay, it's not an issue. And this global transport network has been built up over centuries. It will be centuries before Mars has a comparable global transport thing.
Right.
So therefore, if you want to get uranium on Mars for your city, the odds are you're going to have to get it locally, which means you're probably going to have to get it from much poorer quality ore than would qualify as ore on Earth. Now, there's plenty of uranium on Earth if you're willing to go beyond the high quality ore that is actually used. The average piece of granite is 2 parts per million uranium and 8 parts thorium. And what that means, by the way, is that a kilogram of granite has as much energy content in it in a nuclear reactor as 100 kilograms of oil. Okay. But we don't use that because we have much richer uranium ores that can be found here or there. That can be several percent uranium instead of parts per million. But on Mars, maybe, the average rock might be 2 parts per million, and maybe you can find an above average one that's 1,000 parts per million, but that's still not 2%, which is 20,000 parts per million.
So developing all the technology to deal with those challenges is basically what will benefit not only Mars, but Earth as well.
And also, for instance, breeder reactors. On Earth, we're willing to use pressurized water reactors, which, by the way, I think is a good design. It's why it's lasted so long. But it only gets about 1% of the energy out of the uranium. If you had a breeder reactor, you could use 90% of the energy. But you know why the breeder reactors are not common on Earth?
Why?
Because the uranium fuel is only 5% the cost of the whole reactor. So it's like you've got something that costs you 5% of your total bill, and someone says, well, I can save you 4 of those 5%. You say, well, maybe, but I'll call you back later. It's not something that really turns you on. Now, part of the reason why it's only 5% is the other 95% is grossly inflated due to the inflation of construction costs by regulatory delays. If you had a system where those construction costs were dropped by a factor of 10, so instead of being 95%, they were 9.5%, then it gets 9.5, the 5 starts looking important. And then you say, well, let's try to cut that down and have breeder reactors. But I don't think the Martians will have any patience whatsoever for hostile regulation against building nuclear power plants. And they will build them the most efficient way possible, and they're going to want to have the most efficient use of their fuel. And then beyond fission, there's fusion. Deuterium, which is the fuel for fusion reactors, heavy hydrogen, is 5 times as common on Mars as it is on Earth. Now,
and it's pretty common on Earth still, right?
Well, it's common enough, but the real point is, you see, on Earth, there are so many alternative ways to make electricity. There's fossil fuels, there's the solar, there's the hydro, where there's no, people interested in fusion power, of course, but there's no driving imperative to create it. Whereas on Mars, if you could create fusion power, you're better off in so many ways. You eliminate this whole problem of uranium enrichment, and of course, all these other fuel sources don't exist. So I think that the Martians may well be the ones who are going to be driven to bring fusion online.
Or maybe it's going to be their Earthlings planning to go to Mars and driven to build fusion here to then bring it to Mars.
Well, yes, but then it will be advanced. But I'm going to come back to that subject in a minute about the Earthlings, because I happen to know some. But the British invented the steam engine, but Americans invented the steamboat. And the steamboat required higher pressure steam engines to be more efficient. And it was these higher pressure engines then led to railroads. Now, we needed steamboats because early America, the only real highways we had were the rivers. And sailboats don't really cut it well in rivers. And so we really pushed the development of the steamboat. By the way, you should know that my wife, Hope, is a direct descendant of Robert Livingston, who, in addition to being one of the committee that drew up the Declaration of Independence, financed Robert Fulton to build the first steamboat.
Wow.
Okay, Claremont. But that's another story. In any case, the steamboat, a necessity for frontier America to use the highways of our inland rivers, then leads to high-pressure steam engines and railroads and revolutionizes the world in the 19th century. So that's an example of the frontier driving world-changing innovation. And the steam engine becomes more efficient when it is forced to be packaged into steamboats. Just as, by the way, the first really practical nuclear reactors were in submarines. Okay. And maybe the first really practical fusion reactors will be on spaceships.
Right.
Where that discipline of compactness forces them to become efficient in everything. In any case, you brought up the idea of Earthlings wanting to develop this technology so they could colonize Mars. Well, this idea has crossed my mind, and the Mars Society, which is a nonprofit that I lead, is soon going to establish what we call the Mars Technology Institute, which the business plan here is to start the Martian Inventors Colony here, to devote ourselves to developing the technologies needed to settle Mars and become self-financing by spinning off those inventions for terrestrial applications. So this is, in fact, going to become very shortly a major initiative by the Mars Society. And this is our plan for how to get to Mars, to create a Mars Technology Institute to generate both the needed technologies and to generate the cash income needed to do it. And if we look at the three most remarkable efforts of colonization that occurred in the past 400 years, remarkable because they were not driven by the profit motive. Okay. If something can be driven by the profit motive, it will happen automatically. Mm-hmm. It's almost impossible to stop it from happening. But if something is not a money-making proposition, it takes special effort to make it happen. And these three most remarkable colonization efforts are the Pilgrims going to Massachusetts, the Mormons going to Utah, and the Jews going to Palestine. And, in all three cases, they're driven by transcendent motives. Okay, but also in all three cases, to make them actually happen took strong home front organizations to finance the emigration. And this is still, to some extent, the case with Israel today. There are still organizations that finance Jewish emigration to Israel.
So do you feel like the Mars Society might be one of, or the organization that will fuel that
it's my
Mars
hope that we could grow in size and financial strength and other forms of strength to the point where we could do that. Right. I think that's what Mars will need. Now, there may be other such organizations established. I think there probably will, once it becomes evident that this is a possible thing to do. But we're going to try.
That sounds fantastic. So you are making a great case for why we need to go to Mars. And, I'm in the believer camp. But there are still people on Earth, Earthlings, who say, oh my gosh, why do we spend so much money on space? This is so inefficient. People are hungry in Africa, and there is war in Ukraine and other things, which I personally care about a lot. But then people say that we shouldn't spend anything on space exploration and other things while there are still burning issues here on Earth. What is your answer to those people?
Okay. Well, first of all, my answer is, as far as the war in Ukraine is concerned, is a lot of space technology that has been developed by people interested in exploring the solar system is proving decisive in the defense of Ukraine. Mm-hmm. And this is, in many respects, the first space war. Mm. That is, of course, the real fighting is happening on the ground, but a lot of what determines which side wins is happening in space. The reason why Ukraine is able to take on Russia, even though it's outnumbered 3-1, is because of space-based communications, space-based reconnaissance assets, and space-based precision guiding of armaments. And
like anti-air missiles. Right?
Anti-air missiles. And what about the missiles that took out the Moskva? Mm-hmm. Ukraine did not sink that ship by launching 50 missiles and having 2 hit it. It launched 2 missiles and they both hit it. And the HIMARS, precision-guided weapons, and so forth.
These are guided by the GPS, which is provided by the satellites that are orbiting our planet.
Correct. Okay. So space superiority that the United States enjoys over Russia is a product of freedom. I do believe that Ukraine can and should develop its own space capabilities in both the military and civil areas, that it should be fully a participant in the free world space capability, but also have some of its own, because nobody cares as much about you as you do. And I'd like to be able to tell you that America will always be there for you, but that may not be true. And then
there are also like other issues in the world, from homeless people in San Francisco to hungry people in Asia and Africa. It's like, I keep hearing people like, why do you spend so much time and energy on space? Like, spend it on Earth.
Well, let me just say again, okay, in terms of the advance of the human condition that we have witnessed, over all of human history, but especially over the past several hundred years, it's been driven by the advance of science and technology. And it has to be said that by taking on the extreme challenges associated with exploring space, we develop key technologies that greatly advance life on Earth. And this has been true in every field. And so that's the program, is advance humanity through science and address some of the most challenging issues to push the breakthroughs to the maximum. If you take our Mars Technology Institute that I just described to you, one of the areas we're going to be looking at is ultra-productive crops.
Right.
What could possibly be of more benefit to the poor people of the Earth than having food become cheaper through ultra-productive agriculture? Okay, so how can anyone tell me that they've got a better idea? We have not eliminated poverty through redistribution of incomes. We've eliminated poverty for most cases,
by
in most
creating
places,
abundance.
By creating abundance through science. And so this is our program. And
you're basically making this strong sort of anti-Maltusian case that, if we really innovate and think about the future, there is more than enough for so many people to live on Earth and on other spatial bodies, heavenly bodies, as opposed to those people who say, there is not enough resource on Earth and we should reduce the population and humans are destroying Earth and so on and so forth.
Right. Well, this brings me to another very important point here. Okay. If you look at, people talk about the threat to humanity, and especially until a couple of years ago, almost all the people talking about the existential threat that humanity faced would say global warming. Okay. And some might say resource exhaustion. Okay. But if you look at the 20th century, none of the catastrophes of the 20th century were caused by climate change or resource exhaustion. They were caused by something else entirely.
By wars.
Well, wars, but wars driven by one fundamental concept, which is there isn't enough for everyone. And therefore, we have to kill them to take what is theirs, or alternatively, to stop them from killing us because they want to take what we have.
Zero-sum game.
Yes. Yeah. And this idea of war as being necessary is what drives the idea of tyranny as being necessary. And the tyrants themselves know this, that war is necessary for them. Okay, or a belief in the necessity of war is necessary for them. Hitler said somewhere, he said, the idea of perpetual prosperity and plenty achieved through science is a Jewish plot to undermine the people's belief in the necessity for war. Now, it's not a Jewish plot, but it does undermine people's belief in the necessity for war. And the people's belief in the necessity for war is necessary for the people's belief in the necessity for tyranny. Okay? We have to undermine people's belief in the necessity for war and thereby undermine their belief in the necessity for tyranny and thereby get rid of both tyranny and war. Okay? And this reach into space, this proving that it's crazy to be fighting over provinces when by using our better nature we can develop planets. This is the key program. Now, we have to do some things to hold the existing tyrants at bay until that program can deliver. But that is the program. And that is the way we ultimately solve the problem of the house divided on Earth. And by pursuing science, we pursue plenty, we pursue an unlimited future, we pursue freedom. And of course, while the tyrants are delighted if they can steal some of the works of science, okay, they are against her parent, which is freedom, okay, and they're against her faith, which is truth. The Putin regime is noteworthy for its lies, okay? That is lying, frankly, the way a sow pisses, okay? And in this respect, I think they have outdone the communists, and by a considerable degree, in making lies blatantly, obviously, in your face. Okay, that Putin blows up the buildings in Moscow. People are caught on the street by Moscow cops. They say, "Oh, this wasn't us." The Litvinenko writes a book exposing it. They poison him, but how do they poison him? With polonium, so you will know it was them, and then they deny it. In other words, they make sure you know that they're lying when they lie. Okay, they send an army into Crimea and say, "We don't know who those people are." Okay, the 3 days before the current invasion, they announce, "We're not going to invade Ukraine," and then they do it.
And do it again and again and again and again.
Again and again and again. And they conduct a systematic campaign to destroy Ukraine's electricity generation capacity, and then they blow up a dam, which is a major hydroelectric dam. They say, "That wasn't us." Okay, yeah. While they say that to the outside world, while domestically they brag to the people, "Look, we blew up the damn dam."
Right.
Okay,
right.
They lie in this way, and it's not merely that they lie; it's that they mock the idea of truth. They do not believe there is such a thing as truth, or that truth is in any way important. In other words, they make no pretense here. So a regime like this, which exists on the ideology, there is no truth. That should be what is written on Putin's gravestone. It's the enemy of science in the most fundamental way.
Right.
And science will give us freedom, and freedom will give us science.
It's hard to disagree. So back to Mars. When you're talking about the future settlements and so on, we are getting in the territory of the concept which is known as terraforming of Mars.
Yeah.
Making Mars as a planet livable. Mm-hmm. When I first learned about that concept, I was struck by it as probably the most ambitious engineering project that humanity has ever thought of that is no longer strictly a science fiction. And I have a younger brother, and I remember for his 14th birthday, I gave him a wall poster of Earth and it was Mars as it is today, and Mars as it is imagined after being terraformed with water and green forests and atmosphere and all of that. Tell me about how you think about terraforming Mars. How far out is that possibility, and what will it need from humanity to accomplish that?
Okay, well, first of all, I believe that humans will eventually attempt to terraform Mars. It won't be the first thing we do on Mars. The first thing we do is establish city-states, but which will then aggressively grow in technology and industrial capability and so forth until the point comes when they actually can tackle this challenge. But I believe that they will be motivated to do this both because of the obvious practical benefit to them of having a more livable planet, but also instinct. It's fundamental to life to transform environments from sterile environments to fertile environments. That's the whole history of life on Earth. That's why life on Earth has been a success. Life has radically transformed the Earth.
That's us fighting against the second law of thermodynamics.
It is. It's life fighting against the second law. Life has made Earth a much more friendly to life than it was. And so humans would be contradicting not only human nature, but the basic nature of life if we did not try to do this. So we will. Now, if we talk about the instrumentalities for doing this, okay, if I'm looking at this as myself, who was basically a 20th century engineer. I understand this is the 21st century, but I'm just visiting. I'm a time traveler. Okay. I'm a 20th century guy, okay, who has traveled to this time period. Don't fully understand it, actually. But the, really, sort of. Okay, but the, say, okay, how do we do this? The first thing I want to do is I want to warm the planet up. And we know how to do that. We do it with greenhouse gases that can trap solar radiation. We are doing this accidentally on Earth right now.
Yeah, we have too much of them here, so we can just borrow some for
Mars. Sort of. Except that
need to package it nicely in pallets, and
Well, that has been proposed, but it would be more useful to manufacture it there.
Right.
And furthermore, we know about greenhouse gases that are far more potent than carbon dioxide. Carbon dioxide is the greenhouse gas of the most concern right now with respect to the global warming issue on Earth. But there are artificial gases, in particular fluorocarbon gases like CF4.
Would they be like poisonous or bad? Or
no,
are
CF4
they
is not poisonous. It's inert. And it is used as a refrigerant. And it's an extremely powerful greenhouse gas. So are the chlorofluorocarbons that involve both fluorine and chlorine with carbon. And those were widely used as refrigerants until the 90s, when it was discovered that they were damaging the Earth's ozone layer. And so they have been replaced largely with fluorocarbons, which do not damage the ozone layer, but otherwise have similar characteristics. So terrific greenhouse gases. Now, they don't cause much warming on Earth because we put them in refrigerators and stuff where they stay. But if you were manufacturing these at the rate we currently manufacture them on Earth and not putting them inside of refrigerators, but purposely releasing them to the environment, you would warm Mars by 10 degrees in 50 years. And that's...
And just want everyone listening to us to appreciate that we're talking about a whole planet, which is... was about it's like one fourth in volume of what Earth is.
The Mars has half the diameter of the Earth, which means 1/4 the surface area, which means the same surface area of all the land
of the land, exactly,
of the Earth, because the Earth is only 1/4 land.
So it's still a pretty big planet, right?
Yeah.
And we are talking about changing the atmosphere on that planet in order to heat it up by 10 degrees. And you are saying this is doable within 50 years.
If we were producing producing the fluorocarbons there at the same rate we're doing it globally right now.
Of course, they would need 8 billion people on Mars and
No,
industry.
I don't think it would need.
No, I'm kidding, but it would mean industry, which is pretty serious, which currently supports 8 billion on Earth.
Right, but
that's doable in principle.
In principle, yes. Now, to give you an idea, 10 centigrades in 50 years. The global warming that we've seen on Earth due to CO2 is 1 centigrade over 150 years. So this is 10 times as much in 1/3 the time. But this is, once again, not being done as an accidental byproduct of human activity, but intentionally. Because, global warming can be good if you're too cold. And Mars is too cold.
And then there are more radical ideas like blowing up the nukes on Mars and other ways to bring heat.
But I think those are not sound. There's a number of reasons why. First of all, you need an awful lot of nukes. Second of all, I think that the people who are going to terraform Mars will be the Martians. They are the ones to whom it will be worth doing. And so they're not going to want to nuke their planet. They're not going to want to crash asteroids into their planet. They're going to want to do it using means that are less kinetic, shall we say. So that's a boundary condition on the terraforming process. So now you warm the planet.
Right.
That will cause a great deal of carbon dioxide, which is currently soaked into the soil, to outgas.
So we'll basically start thawing, or releasing. The soil will start releasing the CO2.
Correct.
Which will further heat up the planet.
Correct. Exactly. Substantially. Because now, even though CO2 molecule for molecule is less efficient than fluorocarbons, you're going to have vastly more of it. And that could warm the planet up a further 50 degrees. And if you do that, then large amounts of water, which are currently frozen into the Martian soil or immobilized as glaciers, will melt.
And Mars's average temperature as of now is what?
About minus 50 centigrade.
So chilly.
Yeah.
If you add another 50 or 60 degrees, it becomes pretty much a nice place.
Yes. And so now you've got water flowing. You've got the dry rivers of Mars flowing again. You've got the dry lakes, the dry oceans becoming filled with water. You've got rain. And the rain will destroy the peroxides in the soil, releasing small amounts of oxygen, not a great deal, but some. But anyway, destroy the peroxides. And now it becomes possible to grow plants in the open.
But still difficult to breathe for a human.
Yeah, no, impossible to breathe for humans, but you wouldn't need a spacesuit anymore. That is, there'd be pressure.
Right.
So all you need
because you have atmosphere, you'll have pressure, maybe not as big as you have on Earth.
But enough.
But enough.
Yes. In other words, you could create, say, 1/3 of Earth's pressure, which, by the way, is the same pressure as on the top of Mount Everest. And people can function there if they have oxygen masks and warm coats. And so in that Mars, you no longer need spacesuits. You'll still need oxygen masks. Now, to create the oxygen in the atmosphere, the most logical process is to spread green plants. Okay. Now, if we're talking about the kind of plants we have now, which are only about 1% efficient, to take about 1,000 years to put enough oxygen in Mars's atmosphere to breathe.
1,000 years.
With the kind of plants we have now.
Right.
But if move us 100 years into the future, after you have a century of development of advanced biotech on both Mars and Earth, it's hardly out of the question to be thinking of plants that could be 5% more efficient. And
basically accelerating by a factor of 5, so 200 years instead of 1,000.
Or even faster.
100 years of research and then 200 years of,
oxygenation.
Oxygenation. And then also you'll need some time to actually plant those forests.
Well, yeah, but they could be spread rapidly because one of the things about plants is once you get them going, they do the rest, right? And but here's the thing. I've just laid out a scenario of the terraforming of Mars as envisioned by a 20th century engineer. And, people on Mars 100 years from now are going to watch this podcast. And they're going to say, well, this is really interesting. Here's this 20th century engineer talking about terraforming Mars. And of course, we've done it now, and it didn't take 1,000 years. It took 100 years. And he talked about doing it using fluorocarbon gases and green plants. How 20th century can you get? In other words, they're going to view my Mars plan the way we view Jules Verne's moon mission plan. In 1865, Jules Verne laid out a plan for a human mission to the moon. And he launched it was a crew of 3. He launched them from Florida, okay? They orbited the moon.
He actually guessed that one, right?
That's right. He guessed it right. And he actually, there's logic in it, and he worked it out. And he guessed that right. Well, it was Americans that did it, and they did it from Florida, and they did it in a capsule that orbited the moon and then landed in the Pacific Ocean and was picked up by a United States Navy warship, all as actually happened in the real event 104 years later.
What a genius.
Okay, but the propulsion system he used was heavy artillery.
Right.
A giant gun. Okay,
Yeah.
and you look at that and you say, well, how 19th century can you get?
He didn't really thought out the G's that would
Well, that's right.
would
He
experience.
didn't think out the G's, and also the fact that, frankly, a gun can't go fast enough. But nevertheless, the point is, it deserves a lot of respect, but it couldn't possibly be right because it was a 19th century mind grappling with a 20th century problem. And so I think that even though this is the best plan I can come up with for Mars terraforming, I think it won't be done this way. I think this is the Jules Verne Mars terraforming plan. Okay, and that when it will be done by people who have 22nd century technologies, and maybe self-reproducing nanorobots or something. Okay, and which to me at this point are magic. But which will be the technology of the day.
So there's an interesting tangent here. When you're talking about this, you're basically talking about advancing engineering side of things. The difference between Jules Verne and then what happened 150 years later is not only engineering side of things, but also science side of things.
Okay.
And then there are many people around the world currently who argue that there's hardly any new physics, that we sort of discovered most of the physics there is there within human reach, and they did not expect us to discover anything new within the next 100 years. Where do you stand on that question?
I think those people are wrong. I think that we've only read about the first 3 chapters of a 12-chapter book when it comes to physics. I think physics as it stands now is incoherent. It makes statements like matter cannot be created and destroyed when it clearly was. There's no explanation for why electrons and protons don't blow themselves to pieces because they're made of a single charge that should repel itself into oblivion. There's various anomalies that have been identified, like the galactic rotation is too fast to be held in by the matter that is there.
All the sort of dark energy and dark matter.
But I'm very skeptical of those hypotheses because they're making something up to explain a phenomena that they can't explain. In other words, no one has detected dark energy or dark matter, and it's
just sort of a catch-all sort of term. Both of that, and those are totally different terms.
I would put them in the same class as epicycles. When they had the pre-Copernican astronomy, and they using the Ptolemaic model for motion of planets, and then something would happen they couldn't explain, and they add another a cycle thrown in. And so I think those are ad hoc hypotheses, and I'm quite suspicious of them. The their epicycles. So I think there's new physics waiting to be discovered here. Now, when you discover new physics, whole worlds of technology become possible.
It takes some time for engineering to adjust, but when it adjusts, you have significant changes in the world around, right? So to close up the topic of Mars, let's talk about the timelines a little bit. The timeline to first human on Mars, and maybe first settlement, and maybe Mars being a terraformed planet. How do you see this as we sit in 2023?
Okay, well, the first human on Mars, it's possible, if Musk does not skate off the edge of the ice, we can have the first human on Mars within 10 years. That is...
well, that's pretty conservative, right? I mean, if the Starship flies, first reaches orbit this or next year, and maybe like there's the first window in 2026, or maybe
there's a lot of stuff that needs to be developed besides just the Starship. I mean, Musk says things like it'll happen in 2026. I mean, look, he said the Starship would reach orbit in 2021.
He's famous for his deadlines.
He's famous for his optimistic deadlines.
Yeah.
Okay. On the other hand, he is also famous for the ultimate accomplishments, which are quite impressive. So I think this thing will take a bit longer than Musk is currently projecting. Now, it could take a lot longer if Musk skates off the edge of the ice. Musk is a risk taker, in a variety of areas. And he could fail because the Starship itself fails. He had a very dangerous close run with failure in the first attempted launch of the Starship, which destroyed much of the pad and sent dangerous debris flying for miles. And if someone had actually been killed by that, even if they were people who were illegally present closer to the launch pad than they should have been or something like that, that could have shut them down. There's various court cases about to be litigated over this, which he might win, and in my opinion, should win. But sometimes courts do things that they shouldn't do, and that could stop him. Or he could fail because of any number of other risks that he takes that are completely unrelated to Starship. Him baiting the securities authorities and so forth in conjunction with various stock transactions.
And then basically from what you've previously said, you're saying that the Chinese programs are oftentimes just sort of, how to put it mildly, getting inspired by the work of Musk and SpaceX.
But that would not stop Musk.
What I'm saying is that, and I wouldn't even personalize this to Musk, because obviously SpaceX is a huge organization now, and there are many people there. But if something happens to SpaceX, the chances of Chinese sort of going to Mars on themselves, or NASA and going there by themselves, are also sort of decreased.
Well, perhaps, except that, Musk has really changed things in a way that won't be reversed. That is, regardless of the fate of SpaceX. Musk has proven it is possible for a well-led entrepreneurial team to do things that were previously thought it took the governments as superpowers to do. And not only that, do it in a third the time at 1/10 the cost, and even do things that they had deemed simply impossible, such as having reusable launch vehicles to return to the launch site. He's really shown that. I mean, one has to hand that to him. And what that means, and so he's ignited an entrepreneurial space race. And it's not just the Chinese or Blue, here, Rocket Lab is a company which was not founded by a zillionaire with play money to spend. It was founded by working engineers who found real investors, and they have reached orbit, and they're contemplating a probe to Venus. And they are building a knockoff, not exactly a knockoff, but something with comparable capabilities to a Falcon 9, and actually a somewhat better design in my view, but they have the advantage of experience. And I think this thing, they call it the Neutron, is the next rocket. And there are other people out there that are doing some interesting things. This is going to
And they're launching it out of New Zealand, right?
They launch in New Zealand. I think they may launch out of Vandenberg as well.
Yeah, I think so too. Yeah.
But think about this. New Zealand now has a launch company. It doesn't even have a government space program.
Right.
Okay. Now, if New Zealand could do it, Ukraine can do it.
Right.
And should do it, and needs to do it. But that's a different subject.
Right.
However, this thing's going to go on. Because Musk has demonstrated reusable launch vehicles, the cost of space launch has come down by a factor of 5. This has enabled a whole bunch of business plans that previously were ridiculous to be plausible. And so now you've got giant communication constellations being launched and so forth. And there'll be, there's 3 companies with commercial space stations that they're pushing. And, okay, here's the International Space Station, partly as a result of technology and partly as a result of bureaucracy. This is like a $100 billion project, which is out of the question for a private company. But if you make a space station a $100 million project,
and you make money by tourism and science, experiments, exploration. The same, actually, intellectual property that you're proposing, just, having a bunch of engineers on vacation there.
Well, or not just on vacation. I mean, like $100 million
workation,
is a lot of money to you and me, but it's well within the budget of a Fortune 500 company.
Yeah.
So while most companies wouldn't want to do research on the International Space Station because, first of all, it takes years to get your payload up there. Second of all, you got all kinds of strangers floating through your lab. Why not a Pfizer space station? Why not a BASF space station? Why not a Hyundai space station? And there will be, if you start getting the cost down to kind of money that Fortune 500 companies can wield. And then if the Starship is successful and this, the launch costs have gone from 10,000 a kilogram to 2,000 a kilogram, and now it could go to 500 a kilogram, then a whole bunch of additional plans will become possible. And so this is now been
it's
unleashed.
It's a different ballgame.
Okay, yes. So once again, the fastest
So you're saying
scenario,
10 years to human on Mars, right?
If SpaceX succeeds. If SpaceX fails, it could add a decade to the timeline.
And another 10 years, okay. And then the first human settlement on Mars. What's your bet?
Okay, 20 years after the first landing.
Okay, so we're talking 30 to 40 years from now. Okay. And then terraforming.
Well, that's longer. Although, I think biotech will have a great deal to say about it. Because if we could produce designer greenhouse gases using microorganisms that could self-reproduce instead of doing it with chemical factories and, railroad shipping the ore to a factory and all that, just spread the organisms and have this thing happen, that could enormously accelerate it. So once again, biotech is the real nanotech, at least at this point. It is self-reproducing micro machines, and which we're now learning how to program. And if we can learn how to program them in the right way, then that's why one could imagine terraforming to take place, or certainly begin at the beginning of the next century. If it has to be done by industrial means, it might add a century to that because you'd have to have Martian civilizations grow to, tens of millions of people at least. It doesn't have to be a billion people.
Right. So beginning of terraforming, say 80 to 180 years from now, something like that. And then it would take us a couple centuries or 1,000 years.
This is dependent, I believe, biotech.
Right.
Or ultimately, if real, inorganic nanotech is developed, that could be even more profound. But what we have, at least on the horizon right now, is programmable biotech.
Right. But obviously all of that is, so much uncharted waters. If you think about it, 60 years ago, 60 years ago, we were thinking that by now we would have had, already been on other planets and Mars, maybe Venus, and have flying cars here and so on. But no one could have imagined. Well, no one really imagined, like, or maybe single persons imagine the internet, and the smartphone, and many other things. So who knows? Who knows what the future holds? So to close off the space topic, and as we have many other interesting things to discuss, let's talk briefly about what's beyond our solar system, the interstellar travel. And I think you've proposed one of your sort of inventions and patented proposals were for a nuclear space engine. So talk to me briefly about your thoughts about interstellar travel and other kinds of space propulsion other than what we know currently as chemical propulsion.
Okay, so my own particular innovation, the so-called nuclear saltwater rocket. That's not an interstellar propulsion system. Mm-hmm. That would be an extremely effective interplanetary propulsion system. To go interstellar, we need propulsion systems with exhaust velocities that are at least a significant fraction of the speed of light. Mm-hmm. So, for instance, with
a spacecraft that could be accelerated to at least 10% of the speed of light?
Right.
Are you thinking more?
And 10%. So, for instance, fusion rockets. A fusion rocket could have an exhaust velocity of about 7% the speed of light. With good engineering, you can get a rocket up to about twice its exhaust velocity. So you're talking about travel speeds in excess of 10% the speed of light, but less than 20% the speed of light.
And a fusion rocket would use fusion as a source of energy, but what would be the source of propulsion?
It would be the fuel itself. That is the products of the reactor.
Hydrogen, basically.
Well, it would be the fusion products.
Yeah.
Would be the propellant, which would be helium. Now, if you were using fusion for interplanetary propulsion, which is undoubtedly how it will first be used, you would water down the propellant with, for instance, additional hydrogen, because you don't need, 10% the speed of light exhaust velocities if you want to go to Saturn. So you might water the propellant down 100 to 1 with common hydrogen. And what that does is it gives you more thrust for the same power. How can I put it? There's two important measures of the performance of a rocket engine. One is thrust, which is how hard it can push. The other is exhaust velocity, which is how efficiently it uses its propellant. Now, the high exhaust velocity, if it's extremely high, you get something, it's getting like terrific, 1,000 miles to the gallon. But it takes you a year to go from 0 to 60.
Right.
Okay. So for most purposes, that would not be a practical propulsion system. On the other hand, if you're on an interstellar trip and you're willing to take a year to get to your maximum velocity, well, fine. On the other hand, thrust is how fast it's the pickup of the car. Okay, but imagine you have a car that can go from 0 to 60 in a millisecond. Okay, that'd be sporty for a race, but gets 1/10 of a mile per gallon. Okay, so that's the other end of the ridiculous performance where you have, okay, fine, it could probably work for you if you're doing a drag race, okay? But as a practical means of transportation, it would be very unattractive. So you want something that combines an optimum of pickup and mileage.
As a general rule of thumb, you need more thrust when you're in Earth gravity well, and then you do not need that much of a thrust once you're in space. You have sort of more time to accelerate.
Right.
But it's all relative. If more time means 1,000 years, that's a little bit too much of a time.
Right. But you see, for instance, if you're going to Mars, people sometimes talk about you can get to Mars in 6 months with chemical propulsion. Now, you can come along with electric propulsion systems, and they could do Earth-Mars trip with a fraction of the propellant. Okay, they've got better mileage, as it were. But it takes 2 years to get up to speed. So you say, hey, I don't want to take 2 years to go to Mars. If I can do it in 6 months. So you say, well, how about cargo? Well, maybe cargo, if you're willing to send cargo on the slow boat. It could be more efficient that way. But that becomes a debatable proposition.
Right. But we're talking about Interstellar, right?
But Interstellar, okay.
So Alpha Centauri is like, what, 4 light years away, right?
Yes,
so
correct.
You're talking 10% of speed of light, would take 40 years one-way trip. If you want to get back, you're returning in really an old age, sort of.
I don't think if you're going to Alpha Centauri, you better have made up your mind that you're going one way.
And additionally, it takes some time for you to accelerate to the 10% of speed of light, and then it takes some time for you to sort of decelerate. So it actually turns to be not 40 years, but maybe more. I don't know, 60
50,
or whatever.
or something.
50, yeah.
Yeah, if you're at 10% the speed of light. Now, however, if there's new physics, and I think there will be new physics, although I don't know what that physics will be, then we're talking about the possibility of creating more potent sources of energy. Around 1895, or a little before that, there was a big dispute between the physicists and the geologists. The geologists, looking at erosion features like the Grand Canyon and so forth, said the Earth has to be at least 100 million years old. And they are supported in this by the biologists, who said, look, evolution takes a long time. We couldn't get to where we are in less than 100 million years. But then the physicists said, well, I'm sorry, that's impossible. If you look at the power output of the sun, which they could measure, and they say, if the sun, and they look at the mass of the sun, they say, if the sun was made of solid coal and you set it on fire and it's burning at the current rate, the most it could last was 2 million years.
Right.
So the Earth cannot possibly be more than 2 million years old because you make it of the best fuel you can think of. It just couldn't burn longer than that. So you have to be wrong. And now, of course, the biologists and geologists were wrong, but in the opposite direction. The Earth is even older. It's 4 billion years old.
Yeah, or like 4.5. Yeah.
And the reason why the physicists were out to lunch is because they didn't know all the things there were in heaven and earth, that could produce energy. And then when they discovered radioactivity, then they got a clue. And ultimately, in 1920, when they discovered the curve of binding energy, that relativity showed that mass could be converted into energy. And then very shortly after relativity was proven, they discovered the mass discrepancy in the elements, and Eddington realized that that's what produces the energy that drives the sun, is mass loss due to basically nuclear fusion. But that's what solved it. So in other words, by discovering new laws of physics, they could explain new phenomena and also, of course, release very potent forms of energy that previously had been.
Right. So when you're talking about new physics for interstellar travel, you're thinking artificial suns, something like Alcubierre drive, which warps space. What do you have in mind?
One could think of a black hole drive, which is like an artificial sun. That could get exhaust velocities over 50% the speed of light, which then certainly changes things. But even things that are just off the books right now. In other words, look, matter was created. Maybe matter can be destroyed. And if matter can be created and destroyed, I mean, there's enormous amounts of energy represented by a piece of matter. The nuclear fission, what is it? It's a small fraction, let's say. It's about 0.1% of the energy of uranium is converted into of the mass of a uranium is converted into energy.
Yeah, you mean like the E equals mc squared.
Correct.
That kind of energy.
That's
yeah.
0.1%.
Yeah.
Fusion is 0.4%. Okay, what if there are things that could convert 100% or even 30%? And there's things out there that we do not understand and that we have no clue about any more than those physicists in the 1890s suspected the possibility of converting matter to energy by nuclear fusion. And so there just could be stuff out there that we don't know. I'm sure there's stuff out there that we don't know. The question of whether it leads to such useful capabilities is unclear, but it very well could.
That's fascinating. You recently published your new book called The Case for Nukes. What is it about?
Well, it's about nuclear power, primarily fission, but also fusion. And it's about how the nuclear power is the key, not only to dealing with the global warming business, but with creating an unlimited human future, about creating huge amounts of resources. It's about the fact that there's no such thing as natural resources. There's only natural raw materials, and it's human ingenuity that turns materials into resources. But it takes energy to do that. And by turning uranium and deuterium into resources, we can have unlimited plenty and an unlimited human future, a future in which every person in the world can have a decent standard of living, a future in which it's understood that there's no need for war. We're not going to have to fight over who has the oil in the Persian Gulf when there's infinite energy all around us.
Right. Well, but we sort of already have this fusion reactor in the sky called the sun.
Yeah.
Why do we need another one?
Well, it's pretty far away.
Okay.
And for any given location on the Earth, it goes on and off every 12 hours or so. And it can be blocked out for months on end if you have this thing called winter. So it's an unreliable source of energy. We want controlled fusion. We want the man-made sun. The same power that drives the sun can be put into small, much smaller machines, and be used to produce electricity and be used to drive starships.
Right. So on fusion, I mean, it has been a speculative area, and you, as you've said, went to study it, and you had hope that you will be an engineer working on that. And here, decades later, we still do not have it working. There is this fascinating company called Helion Energy that I've been following. It's trying and promising that they'll bring fusion to us in like 5 years, and actually commercial fusion. What are your thoughts on Helion in particular, and maybe some other designs that you find promising?
Well, my thoughts, Helion is John Slaugh's company.
I'm not sure.
I believe so. Okay.
They basically they try to make these two sort of toroidal shapes of plasma,
field reverse configurations. Yes,
pulsating. Yeah.
No, that's an interesting concept. In fact, Slough was a professor at the University of Washington where I did my graduate work, and he's a very sharp guy. But more broadly, what's happening in fusion now is an entrepreneurial revolution.
Same that happened to space with SpaceX.
Correct. Now, Musk has made no contributions to fusion except set an example that while he is not interested in fusion himself, the success of SpaceX has incited investors to look at fusion in a different way. They said, maybe the problem here is the same problem as we had with reusable space launch. Maybe the problem isn't fundamentally technical, but institutional. It's the wrong kind of people, the wrong kind of organizations doing it. And so you actually have a whole bunch of entrepreneurial fusion companies getting serious investment money, 100 million, 500 million. I think Slough got 800 million dollars to pursue these concepts. And these companies are not pursuing this on the 50-year timeline like ITER. They're pursuing it on 5-year timelines. And so whether it's going to be Slough or Tokamak Energy in England or Commonwealth Fusion in Boston, one of these guys is going to succeed.
Would you expect us to have a fusion breakthrough within the next decade?
Yes.
All right. Looking forward to it. So a little bit getting back to fission, right, which has been sort of having strange, undeserved bad rep, I would say. The Germans infamously shut down all their reactors, and Ukraine, both famously and infamously, a place for one of the biggest Chernobyl catastrophes, but also currently as very dependent on fission, especially after Russians bombed our infrastructure for the whole winter. There is this concept of LCOE, the levelized cost of energy, which, people who follow that, they argue that actually nuclear fission is very expensive if you account for things like storing the fuel and all the safety and security measures and all of that, at least referring to the designs of reactors that are currently in existence. What do you say to them?
First nuclear fission reactor was the one in the Nautilus. It took 3 years to build, including the submarine. The first civilian nuclear power plant was Shippingport. It took 3 years. In the 1960s, we went to much larger nuclear fission plants, and they still took 4 years to build. Then what happened, however, was in the 70s, hostile regulation was introduced, and it expanded the time it took to build a nuclear fission reactor from 4 years to 8 years to 12 years, and now 16 years. And in my book, The Case for Nukes, I have data that shows that the cost of the nuclear power plant goes up as the time to build it squared.
Wow.
And that is it's the overwhelmingly dominant cost of nuclear fission is the construction cost, and which has been inflated by hostile regulation. Now, so sure, I had this debate with this German Green says, we're shutting down our nuclear power plants because nuclear power costs more than solar energy. You're out of your mind. You already spent the money on the nuclear power plant. Right. They were shutting down those plants. Well, those Greens were not the people who made the decision, but the people who actually did make the decision were doing it in order to cement an alliance with Russia. And they were literally shutting down their nuclear power plants in order to fund the Russian war machine.
Do you suspect that's like corruption?
Yes.
That's like political influence, not sort of a scientifically, rationally made decision to shut down?
It absolutely had nothing to do with science. I mean, the rationalization used, we have to shut down the German nuclear industry because of Fukushima. When was the last time a tsunami swept Germany? It's ridiculous.
It's amazing how the whole nation could have been basically brainwashed.
Yeah, well, it's Germany. No, to have fantastic abilities to hold on to a viewpoint regardless of facts. But no, it's absolutely bizarre. And then even now, when these are the people that will more than anyone else be screaming about the existential threat of global warming, they choose to shut down their nuclear power plants. When they don't have the Russian gas, they still prefer to burn coal. So in fact, Germany right now has 5 times the carbon emissions per unit electricity produced as France right next door.
Right, insane.
And so it has nothing to do with their environmental commitments. It certainly has nothing to do with economics. It was enormously economically destructive. It had to do with, one must say, a recurrent theme in German geopolitical strategy going back to the 1700s of making an arrangement to split domination of Eastern Europe with Moscow, which is why I know in Poland they called the Nord Stream pipeline the Molotov-Ribbentrop pipeline.
Makes sense.
And there's a good name for it. And so, no, the German sabotage of their own nuclear industry, nothing to do with economics, nothing to do with global warming. If they were cared about global warming, they'd build more nukes, not shut down the 22 gigawatts of their own power.
And then there are new types of reactors, which you also mentioned in the book, that can further make nuclear energy cheaper, more safe, easier to use, right?
Right. Now, it's the regulators that have stopped the improvement of nuclear reactors. That is, for instance, breeder reactors, which would get like 90 times as much energy out of a given amount of uranium and have 1% as much waste for a given amount of power. Who's going to try to do a new type of nuclear reactor when you're dealing with hostile regulators who are giving you all kinds of problems in starting reactors that they're completely familiar with and which have been, over 1,000 of them have been built over the past 60 years, and you come along with something new. In fact, early in my career, I was involved with the conventional nuclear industry. And I was with the Washington State Office of Radiation Protection, which had some authority over the Trojan plant, which was in Oregon. And they were having a problem with corrosion in their secondary loop because it was made of carbon steel instead of stainless. And the utility said, we made a mistake. We should make this a stainless steel so we don't have to keep replacing the damn loop. The Nuclear Regulatory Commission refused to let them do it. They said, your license said it would be carbon steel, not stainless steel. And so we won't let you make that change. So they literally would not let them make an obvious improvement in their own plant.
Bureaucracy be damned.
Yes.
On that note, let's talk a little bit about the U.S. politics.
Yeah.
That's where bureaucracy is also present and some other interesting processes. And we've talked already about Elon Musk on many good things he's done. Strangely, lately he has become a part of the U.S. politics as well. It seems to me like he got bitten by Donald Trump or something like that. What is happening with Elon, with his statements? They're sort of divisive for the U.S. politics and his views. Why is he doing this? What's your point of view?
Well, a couple things. Elon Musk was for a long time kind of a political chameleon who was able to adapt to whoever was in power. He was close to Obama, then he became close to Trump, then he left Trump. But one thing is, I think one thing that happened with him was the 2-year delay in regulatory approval of the Starship launch. Certainly predisposed him to a negative view of the federal bureaucracy. And of course, the Democrats are largely allied with the federal bureaucracy. So that kind of moved him in that direction. But I think also what happened with Musk is, Musk's greatest strength is also his greatest weakness. Perhaps that's true of most people, but certainly true of him. His greatest strength is that he wants eternal glory for doing great deeds. And furthermore, he defines a great deed as a great deed for the human race. Okay? So he has a humanist impulse in that sense. So the positive side, that's why he did SpaceX. Okay? Instead of doing casinos or something. Okay?
Right.
Okay, that's why he did Tesla.
Right.
He wanted to make humanity multiplanetary, solve global warming with electric cars. These are profound things, etc. The Russians are pretty good at calibrating someone's psychology, and Putin especially, I think. And they got his number, and they made an approach to him, and they said, look, you can be the guy who stops nuclear war. Because what the Americans don't understand is Crimea is an existential issue for us. We will go to nuclear war rather than lose Crimea. And so you have to stop this thing from getting that far. And they flattered him in this way, that he could be world historic as the guy that stopped nuclear war. And so he made some statements basically advocating a so-called peace plan, which is basically the Russian plan, give the Russians what they've already taken. Oh, we'll have a free election in the Russian territories to decide where they should be. Like all the other free elections there have been in Russia in its history. And then his ego became bound up with this idea that he could stop the war with this peace plan, which was basically give the Russians what they want.
So he became a victim of Russian propaganda, although
yes,
he is a smart man.
He is, but
they sort of stroked his ego.
Yes,
that seems like a story out of a novel, right? It's so simple.
Yeah,
it sounds so simple.
No, Elon Musk could make a great Shakespearean character.
Right. But look, it's not only Ukraine and sort of Russia that make me wonder of what's happening with Elon. It's also many of his political statements, including sort of his attacks on the left and this, the way he behaves as once he bought Twitter, and so many outrageous statements he's been doing, especially lately. Is there something that happens to a human that goes so high, so close to the sun, that changes that person?
Well, I think they become incapable of taking negative feedback. They lose the virtue of moderation. I was actually asked by Time magazine, in conjunction, Elon was Man of the Year in December 2021 or so. And since I knew him, they asked me a lot of questions about him, and my comments, mostly very supportive, are scattered throughout the article. But I also had the last word. And the last word was the question, if Elon should fail, what will make him fail? And I said that if Elon should fail, he will fail for the exact same reason that Napoleon failed in Russia. Which was that he had succeeded in everything he had done previously. There were all these French generals who told Napoleon, why don't you just take Poland and call it good? We can do that. The Poles will love us forever. We'll have a strong ally in Eastern Europe. Done. What's not to like? And Napoleon said, you people always advocated caution before. You were always wrong. I was always right. The bold course wins the day. We're going to Moscow. And, if Elon should fail, it will be because he succeeded at everything that he had tried. Until he failed.
Right.
Yes. But in other words, the inability to take negative feedback, the inability to, take advice. Look, why don't you rethink this a little bit before you go ahead? And, I advised him not to buy Twitter.
Right. And I should note this for our audience that you know him pretty well, and he famously became one of the big donators for the Mars Society before you met him, and that's how you met him, right? And
he gave a $5,000 donation before I met him, and then I met him, and then he gave $100,000. But yeah,
yeah. So and then he was inspired by your writing and your proposals to found SpaceX, among maybe other things that also influenced him. And then he moved on to try to buy a rocket from the Russians and all that. The rest is history.
He tried to buy a rocket from the Russians, and they viewed him as a stupid rich kid who they could rip off, and
they spat on on his shoes, right?
I don't know about
that. Was
that.
the story.
Okay, well, in any case, Musk knew business, and he knew these people were crooks, and he had it with them, and he decided, look, if we're going to get a cheap launch vehicle, I'm going to have to create the company to build it.
Right.
Okay. Yeah.
Right. So you know him pretty well, right? And so I think your sort of qualifications are qualified here. But it's not only Elon. I was about to talk about the U.S. politics, and there are like so many supporters of these, outrageous ideas right out of Putin's propaganda mouth. There's David Sachs. There is a whole sort of wing of the Republican Party.
Tucker Carlson.
Oh my gosh, this is the worst probably. The whole wing of the party which advocates these ideas of, let's give away some of the Ukrainian territory to Russia just to avoid the nuclear war. And it seems like that idea should have been flawed within their own framework of thinking, because if we show to the world that a country with nukes can attack another country and gain territory and get out of it without losing, get away with that, then the only way for other countries to be safe is to get nukes. And that leads to global nuclearization. And you not only have the Iran nuclear problem, you have another 10 or 24 of those, which in its turn makes America and American entrepreneurs and American citizens less economically prosperous, less safe, and it's not making America great again, not at all.
No.
So how does that fit into those people's minds? Are they like sort of consciously and really sort of fairly believing in what they're saying? Are they just being ignorant? Or is there like a double bottom to that?
Okay.
They have a different agenda.
Okay. Now, I don't think this is the case with Elon, but I do think this is the case with a number of the other people that we have mentioned, that there's Russian money involved. I do. I think that some of these people have been paid to be Russian agents of influence.
Or influenced in other ways.
Or influenced in other ways. But there's no question in my mind that Tucker Carlson is doing propaganda for the Kremlin, or that David Sachs is a Kremlin asset. And he's particularly unfortunate because he has a friendship with Elon and goes way back. And so that's in other words, they found a way to try to whisper in Elon directly, but they also have this other character out there. Yeah. So that's bad. Now, I don't think, though, Elon is interested in Russian money at all. I think he's interested in having the fame of having stopped the nuclear war.
And also
yes.
It also seems like there is a lot of sort of internal American politics, that part of the Republican Party is just saying that Biden administration is wrong just because it's another party and they have to be saying something.
Yeah, but the thing is this. The more traditional way the Republicans would say he was wrong would be by saying that
he's not supplying enough weapons to Ukraine.
And there's plenty of running room there. There's plenty of very solid grounds for criticizing Biden. We knew the attack was coming. He refused to send arms before the invasion.
Ronald Reagan must be turning in his grave.
Absolutely. And there's certainly Reagan Republicans out there who are spinning, but but they don't have control. And there's a few of them that are running in the primary. Nikki Haley, Mike Pence, are saying that Biden's problem is that he's too weak and so forth. But they're afraid to take on Trump, who has a cult built around him. So rather than, they also need to be attacking Trump for saying Biden's policy is too strong, he's exactly the opposite of the correct policy. You would think that, Biden is wide open here to be attacked from the right. And instead, literally, in traditional terms, Trump is attacking him from the left. He is. I mean, he's attacking him on the basis of pacifism. And so it really is quite outrageous. I was an active Republican until Trump got the nomination. I quit when Trump got the nomination. I knew what he was, even at that time in 2016. I had been in Moscow in May 2016, and all the Kremlinites coming up to me saying, "So, Dr. Zubrin, don't you agree with Mr. Trump that NATO is obsolete?" No. But they were totally in his corner. And but it's amazing to me. And it's amazing to me what people will do to go along. There's a few voices out there. Now, who knows if this indictment actually catches fire? The first indictment was no good from the New York Attorney General, the Stormy Daniels stuff. That was too lightweight stuff. And in fact, that only convinced the Trump fan club that, they're going after him for anything they can think of. Okay. But this one is more substantial, classified documents.
Right.
And we'll see if they can actually nail him, if they really want to nail him, because you want to know something. The Democrats in the recent election were boosting Trump-allied candidates for the Senate and the House in the primaries on the
because he was the convenient candidate.
Well, because they'd be easier to beat because they're such obvious lunatics.
Yeah.
And many of them were beaten. And for a while, there was some hope. Well, this sure shows that Trump's an idiot and not good for the Republican Party. And here's DeSantis, who had endorsed some winners. Maybe he can knock Trump out. But then DeSantis decides to come off on Trump as Trump light, saying, well, why should we be concerned about a war between two Eastern European countries over territory? As if, where's our dog in this fight? And that cost him a lot. But then, okay, so then you...
So look, this also sort of brings us to another issue, which I think is even bigger, and it's an issue of this sort of divided political spectrum in the U.S., which you currently have these groups of two groups of people which are so far from each other, and any attempt of a debate turns into some sort of a scandalous, screaming conversation kind of thing. Why is it so that two great American parties got so far from each other? And what do you think is needed to fix that and to bring them back to, a house less divided?
That's an interesting question. The last time we were severely divided, really, as severely as this, was the 30s, and it was the Japanese attack on Pearl Harbor that united the country.
Do you think another catastrophe like that is needed to,
No.
make the country come to its senses?
Well, I think if you want to know, okay, look, there is a useful process going on. If you look at the Biden administration itself, okay, because there was this problem on the left as well. There were people in and around the Biden administration who were totally opposed to any arms to Ukraine prior to the invasion, people like Sam Sharap and others, and in fact succeeded in having the administration decline to provide any arms prior to the invasion. Oh, this will provoke the invasion, even though we knew the invasion was on. Okay, and the other people saying, no, this will deter the invasion, which is the correct policy. Okay, so the left-wing group had their way, and they were discredited by the invasion because what they were selling was don't send arms and there won't be an invasion. And then there was. And so they're losing influence in the Biden administration, step by step, too slow, but it's happening, okay? And it has to also be said that
when I say about house being divided, I not only mean like the Russian invasion of Ukraine, I also mean things like cultural wars and a variety of different healthcare, so many different issues.
I understand that. What I'm saying, though, is
immigration.
Well, okay. Some of this stuff, I mean, the immigration thing was poisoned by Trump and the alt-right. Because, like Bush or John McCain had a very moderate, almost liberal immigration policy, because anti-immigration is anti-free enterprise, and it's anti-Judeo-Christian, and it's against the principle in the Declaration of Independence that all men are created equal, and it's against American tradition. So it's actually not a conservative position at all.
Yeah, the question is how to handle that, right?
Okay, but if Trump is knocked out, okay, and if the United States comes to understand this war, okay, as our war, which some people are beginning to understand, and they understand that Iran and China and North Korea, okay, that this is one thing here, and what it actually stands for, and the threat that it represents in a global context, okay, then people need to get serious about this thing. And we have to start, and certainly there's a number of sins on the Democrat side here. The suppression of American energy production helps the enemy. Get real here. Why are you asking the Saudis to increase production while suppressing American oil production? This kind of thing. The nuclear power. If there's a reality principle here. And then there's something else, okay, and I will tell this. What you people are doing here is amazing, and you are winning the hearts of Americans, the resistance, the courage. They see it, okay? And there's way anybody can see it and not say, I admire that, and I want to be on the side of the people who I admire.
Yeah. Okay. If any nation in the world can sort of relate to Ukrainians fighting for freedom and liberty, that's the United States.
Right. But you know what it is? Okay, let me tell you. You know the scene in the movie Casablanca?
Sure.
Okay, where, what's his name? Victor Laszlo. Okay, he's the committed anti-Nazi. Okay, everybody else in the place are just, they're lost souls, right? Okay, they're living in this limbo. They have nothing to live for. And he comes down, okay, the Germans are singing, whatever, it's the Watch on Rhine or something.
Yeah.
And he's disgusted with it. He walks up to the band and he says, play the Marseillaise.
Yeah.
And the band leader looks at Rick and he says, should I do it? And Rick says, yeah. And and the whole place stands up. And all of a sudden, these people have their souls back. You see, his example, then they play the Marseillaise, and they all have their souls back. And what Ukraine has done is play the Marseillaise. That's what you've done. The leaders, lost souls, Schultz, Macron, okay, look at them. Look at the kind of things these people were saying 6 months ago.
They're standing up and beginning to sing.
That's standing up and beginning to sing. And that's what's going on here. So you are not without agency here. You are the most powerful force right now in restoring the soul of the Western Alliance, restoring the soul of the West. And I believe that this will happen, and this is why I believe that you will prevail this time, and you're going to win because you're in the process of giving America and even Europe its soul back, and
I certainly hope so.
Okay, and that's why I'm here.
So I cannot say how much I appreciate you coming here all the way, and thank you so much for this wonderful conversation. It's been an honor, and I really hope to meet again and discuss the bright future we have ahead with the tyranny defeated and the humans on Mars ahead and the nuclear power shining for us. Thank you so much, Dr. Zubrin.
Well, thank you.